Hello and welcome. Man, it is good to see you again. Now, as you may have noticed, speculative evolution, speculative zoology, or just Spec Evo, as I like to call it, it's been taken off lately, and I don't know if you've noticed that, but it's with a good reason. And it's a unique niche that involves a lot of artwork and scientific conjecture. And the big player right now is, of course, All Tomorrows by C.M. Koseman, but as it turns out, that's just the tip of the iceberg. Now, if you aren't familiar with the concept of an iceberg, it's basically this. If there's a topic that can be divided up into different categories, it can be an iceberg. So at the top of the iceberg, you have the information that most people know. The middle, which is usually a middle tier or a few, this is the information that some fans would know, somebody who's interested in the topic. And then deep under the water, where most of the iceberg is usually the obscure information reserved only for the hardcore fans. And this iceberg image was obtained from a subreddit called Speculative Evolution, which is only fitting, and a user named PesterJest, who I will link to in the description, made it. So here's the thing. The mysterious world of Spec Evo involves a lot of, as you might have guessed, speculation, and because of that, it often drifts into the realm of world building, as it's called, which is the process of inventing a whole new world from things like the ecology, physics, flora, fauna, earth science, culture, everything that might be part of a world that we're just inventing, basically. A lot of times it's used for the process of writing novels, especially like fantasy novels, where you're inventing whole systems of like magic and culture, or maybe the world of a video game might apply as well. Most recently, like in the video by Wendigoon called The Mystery Flesh Pit National Park, which he didn't make up, but he covered, is fascinating little bit of world building. So, of course, the idea of making up an entire world is where the Venn diagrams of speculative evolution and world building intersect. And so with that out of the way, let's just jump in to tier 1 or level 1 of this iceberg. And we begin on the little place called Skull Island from the Kong universe. Way back in 2005, when the one true King Kong movie was released, there was a book released by Weta Digital who did the visual art for it, the visual effects, if you will. And this book, I could not be more impressed with the work that the artist put into these designs. Not only do you get the artwork, but they went to all the trouble of incorporating descriptions, binomial nomenclature, behaviors, and it's like a field guide for these fictional animals. It's amazing. Of course, there have been other Kong movies, I will acknowledge, which include their own form of speculative zoology. But one thing's for sure, everything on Skull Island wants you dead, and it wants to be the one that kills you. From the freaky insects to the dinosaurs to the Pteranodon, which is from a deleted scene I found on YouTube, and that's from the 2005 movie. It's very disturbing, as are most scenes, honestly, on Skull Island from that movie. And the more recent Skull Crawlers, which you may have seen in 2017's Kong Skull Island. If you visit Skull Island, let's just say you're going to have a bad time. That's clear. I saw the Peter Jackson King Kong when I was much younger, and the scene with the insects in the pit, the worms, if you've seen it, you know the exact one I'm talking about, disturbed me for life. Anyways, it's still super interesting to think about how all these different species would adapt to such fierce competition. Obviously, if everything wants to kill you, and to be the one that kills you, there's a lot of competition amongst these predators, and it seems for every herbivore that there is, there's like 2 or 3 carnivores designed to hunt it. Kind of seems like every predator fills a certain niche. In the mud, you have worms. In the swamps, you have the pteranodons I mentioned. In the plains, you have theropod dinosaurs, and the forests have all kinds of crap. It's basically like real life, but on steroids. So you can't really get that book that I mentioned by Weta Digital with all the stunning illustrations and information because it's out of print, and unless you want to pay a ton of money on eBay, just check out the wiki, which I will leave a link to in the description. Next, we have what's known as the Fermi Paradox, and that is basically this. If the universe is so big and so old, where are all the aliens? Mr. Fermi himself famously asked this question around the year 1950, and it's been known since then as the Fermi Paradox, which any sentence that has the word paradox in it is cool, in my opinion. So to answer that question, where are all the aliens? A recent study found that there's only about a 50% chance that any aliens are out there, and so as a result, there's a 50% chance that we're completely alone in the universe. But honestly, who the heck knows? Nobody does. Now, not to get too far into the weeds here, but the Fermi Paradox is heavily associated with what's known as the Drake equation, which uses a product of 7 factors to estimate the number of extraterrestrial civilizations in our galaxy. So I'm not a mathematician. To say that is a huge understatement, but I'm going to try to knock it out here. So these 7 factors basically are, first, they're starting broad, like what are the odds of this? And if the odds of that happen, then what are the odds of this happening? And so it really just moves down the list of more specificity. But it starts with the rate of star formation. That's the first factor. What is the rate of star formation in the Milky Way? And that's the only one we know with any accuracy, and we know that it's about 7 stars per year are formed. Next is the fraction of those stars which have a planetary system, which again is tough to say, but there's a range of about 20 to 60%, though it could be much higher. The next part of the equation is what is the average number of those planets that are able to support life? Again, very hard to say how likely that is, especially if you believe in the rare Earth hypothesis, which states that the occurrence of life is just extraordinarily unlikely. Apparently, the rare Earth hypothesis takes no account for alternative biology, but still, Drake himself in the equation used a value of 2 for this factor, but it could be much lower than that. And next we have, what is the fraction of those Earth-like planets where life actually appears? So yeah, if other life-supporting planets exist, what are the odds that it would actually have life on it? Some smart people, scientists, have suggested that life is inevitable if a planet is able to support it. So, who knows? But if the idea of panspermia is true, then the likelihood of those habitable planets actually having life is much higher. And we'll talk more about panspermia coming up. Next, we have, what are the fraction of those life-bearing planets that have intelligent life? This is completely unknown, but again, many smart people believe that intelligent life is inevitable given enough time. However, it's also likely that most life would go extinct before reaching intelligence, so that's another thing to throw in there. And this, of course, does not account for that. Next, what is the fraction of those intelligent species that are also able to communicate at an interstellar level, which is much harder than you would think? There's just no way to know how likely that is. And so, since a species could be wiped out early, or perhaps they just have no desire to develop technology, the idea of an alien civilization having the ability to communicate but not wanting to develop technology to do so is kind of interesting. In All Tomorrows, you had the bug facers who did not want to take part in communications outside their planet because they were afraid it would invite an alien attack. And then in Man After Man, you have the memory people who could remember the fact that humans once developed technology and had nothing to do with it because of the disaster that it brought upon them. So that's kind of interesting, making the connection there. Anyways, but what if they developed a more efficient method of communication that we just couldn't pick up on? So there's, you just don't know. And then finally, you have the time span in which a civilization is around and able to communicate. On Earth, some scientists estimate that the average lifespan of a species is between 2 and 4 million years. And that would be just a small blip for a more advanced civilization. Now you need to solve for n, and so using these estimates, how many likely civilizations are there in our galaxy? Or just anywhere, I guess, really. I don't know. But it's probably between 1,000 and 100 million, so not a huge range there. It's possible that there are no other civilizations, and maybe there are, but we just can't communicate. Or maybe they don't want to talk to us. And that is what's known as the zoo hypothesis, or at least incorporated into it, but we will be talking about that later. Very interesting. So what does all this have to do with speculative zoology, you may be asking? Well, half the fun of the speculative part is just imagining what life might look like on another planet. Maybe it has lower gravity, higher gravity, or maybe just it's only water, something like that. But you can't have any of this conjecture without first establishing what the likelihood of these beings is existing in the first place. Or something. I don't know. Next, we have the present-day Megalodon. Let me ask you a question. Have you ever seen the feature film The Meg, starring Jason Statham? Or have you ever seen the Discovery Channel documentary that people thought was real, that covered the idea that the Megalodon still exists? Well, what if that documentary wasn't fake, and what if the Megalodon was real? Where would this thing come from? Who were its ancestors? These are the questions we need answers to. Personally, I feel like this falls more into the realm of cryptozoology, which is a video for another time. But of course, I don't know, maybe it has to do with to be honest, linking this to speculative evolution is tricky for me. I'm not really sure how it plays into it, but maybe just not knowing how the Megalodon might have survived this long, or what changes it may have received since its ancestors died out, or maybe the fact that it didn't change at all is interesting. I don't know. It has something to do with it, but to be honest with you, I don't know what further information we would need after seeing the hit 2018 feature film The Meg, starring Bing Bing Lee. But it's on here, so I'm talking about it. Next, we have the concept of humanoid aliens. So here's the question I've always had. Is the human form the most likely shape for aliens to have? And it turns out the answer, according to some people, is kind of. So if you watch Star Trek or Star Wars or some other science fiction film, you might have noticed that most of the aliens look like humans. Generally, they have a face that we would recognize, usually a head, 2 arms, hands, feet, 2 legs, stuff like that. And it's all basically laid out the same way. It's always bothered me because even in big budget movies like Independence Day or something like that, we still see that the aliens are pretty much humanoid. So is it possible that bipedal humanoid aliens exist? Because evolutionarily speaking, it makes the most biological sense. I didn't used to think so, but there was way back in the 17th century a guy named Christian Huygens, so bad at pronouncing names, but he thought that the human body plan was most likely to happen even on alien planets. Like bipedal shape just makes the most sense with your cranium up top. But he did allow that some of those aliens might have exoskeletons or some other alternative biology that we may not recognize as much, but that body plan would be similar. A lot of scientists agree that the human body plan does make a lot of sense, so who knows? Maybe my frustration with science fiction was unfounded. I don't know, but probably not. Next is a single word, Artifexian. Now, if you haven't heard of him, Artifexian is a channel right here on https://www.youtube.com, and he covers all things world building. So there's the other half of that Venn diagram where these two intersect, and let me tell you, what he talks about is very, very interesting. It's stuff I would not have thought of if we're making a fictional alien race, or just maybe humanity, a story taking place on another planet, something like that. We're not just talking about species, we're talking cultures, languages, earth science. Everything this guy talks about is fascinating. I hadn't heard of him until researching this, and I binged a lot of his videos just because it's interesting. I'm not even writing a story, but basically, if you want a deep dive on world building and what other worlds could look like, this is one to check out. Of course, this is on the first level of the iceberg because the guy is pretty popular. So I'll leave a link on the description. If you haven't heard of him, check him out, and if you have, watch some more of his videos. Now, next we have carbon-based life, and I don't know why this is on the iceberg per se, because unless I'm mistaken, all life, or almost all life on Earth, is carbon-based. So I'm not sure where the speculative part comes into play here, unless we're thinking of the idea that maybe we send a probe to space and we find life on another planet that is also carbon-based, despite maybe not having carbon in its atmosphere. In its planet. I don't know. But there's a couple different ways it could go if we just look at it from the idea of just carbon-based life at face value. We are that, so there's not a lot of speculation involved there. So unless there is something I'm missing here, and there probably is, let me know in the comments, and if so, I will unsubscribe from myself. Next is the idea of living fossils. Now, I know I don't have to tell you about living fossils, but I'm going to anyway. Have you ever heard of the coelacanth? Or have you ever caught one in Animal Crossing? Because if so, please tell me how you did it. The coelacanth is a fish scientists thought went extinct 66 million years ago. But oh, how I would love to have seen the look on those scientists' smug faces when one showed up in a fisherman's net way back in 1938. But as it turns out, the finding of a creature that scientists thought went extinct and previously only existed in the fossil record is not all that uncommon. It's happened quite a few times with wasps, lobsters, urchins, and plants. I suppose that this has something to do with speculative zoology, but I'm not really sure how to connect those dots. My best thought is that it's on here because perhaps for some people, these species that were largely unchanged for years could shed some light on what would have previously only been speculative. I don't know. Next, we have Star Trek Aliens. Now, Star Trek, it's been around for a while. A lot of people seem to like it. And as you may have noticed, if you ever watched any of the series or the movies, Most of the aliens are humanoid, and you may recall from earlier in the video when I talked about this exact same thing, humanoid aliens. Now, of course, they have the humanoid shape because of their budget. They can't go doing CGI all over the place and pay for it, so they just put makeup on people. That's fine, but I mean, it's as creative as it can be with budgetary constraints, so that's why they had the shape. But how likely is it? Again, not sure. But I mean, you have these different species on Star Trek, like the Betazoids, which are telepathic, but they look like people. The Gorn, which are lizards, but they look like people. The Vulcans and the Romulans are people with pointy ears or slight tweaks to their anatomy. Now, what if maybe a lot of these species look like humans because they're extreme examples of convergent evolution? That could be, but it does seem extremely unlikely to me, and I'm an expert. So why might all these species have adapted in these ways? What advantages, for example, do pointy ears or ectothermic bodies have? Well, it's hard to say because there isn't a ton of detail given, at least in the brief research that I did, because I'm not going to lie, I haven't watched a lot of Star Trek, so maybe they go into a lot of detail that I'm unaware of. If so, let me know. That is all I have to say about that. Next, it's the planet temperature calculator. This one links right back to that concept of world building. Sometimes when you're interested in inventing a species or determining how life on another planet might adapt to certain atmospheric conditions, you need to estimate what the temperature of that planet might be. It just goes with the territory. If you want to invent a species, you need to know the temperature of their planet, but you can't just make something up. If you want to describe how they live their lives, what kind of shelters they're building, what kind of clothing they wear, if they migrate, there's so much that goes into this. So how do you figure it out? Well, if you can describe how massive the nearest star is, how far away that star is from this hypothetical planet, and how much of that star's light is reflected by the surface of that planet, then you can get a great idea of what the average temperatures on that planet might be. Now, that is a pretty cool way to incorporate science into world building, which I love. And there are websites out there, just Google it, that will do all of that hard work for you. You just plug in some stuff and it'll generate an average surface temperature for that planet. So if you want to write your own piece of Spec Evo, you can use one of those sites to help. And I don't know, maybe you could call it all days after tomorrow. Next is the concept of convergent evolution, which is when, as you may know, it's when two species on completely unrelated evolutionary branches end up developing similar characteristics. For example, bats have wings, and so do birds. Can you explain that? So in reality, the idea of convergent evolution is critical to the concept of speculative evolution, because after all, we only have life on Earth as our point of reference for, reality. So if we imagine that an alien species is similar to us in that it has eyes or hands or a digestive system that is similar, then by definition, that would be a convergent evolution, because we have those things. So if somebody else does, it would have had to evolve them similar to the way that people did. So the fun part is figuring out in what different ways those characteristics might be incorporated, adapted, and used in their respective environments. So that's how convergent evolution can come into play for speculative evolution. Next, we're going to talk about a game that I love, and I'm super excited to talk about it. It's Subnautica. And if you aren't familiar, Subnautica is a survival/horror/thalassophobia generator, which it takes place on an alien planet, which is mostly covered in water. And there's lots of ocean life, from what are known as bladderfish to sand sharks to terrifying leviathans. And I came to know each of these species intimately because, well, you just have to play it if you haven't. And what's cool about the game and its sequel, Below Zero, is the developers and the artists took a lot of care to match each species' characteristics to their unique environments. So in the game you have deep sea areas, kelp forests, shallows, and each species that you'll find in those biomes, there's like cave systems and stuff as well, appear to be uniquely adapted to those. For example, the deep sea fauna like the amp eel and the ghost ray have biological means of creating light, or bioluminescence is the word I was looking for. Shallower reefs, you'll find the bladderfish. The kelp forests, you'll find stalkers, and those are interesting because they like to hide and ambush in a way. It just seems like great care was taken to invent creatures that could easily exist in any one of those biomes, and therefore they just appear well adapted. So if that's not speculative evolution, then I don't know what is. And I can't say enough good things about those games, so definitely check them out. I've been playing Below Zero on the Nintendo Switch, and it is a ton of fun, so definitely check those out. So for this one, I'm not that smart, so I'm going to read a paragraph from the Spec Evo wiki on alternative biochemistry. And here it is, in relation to alternate plant pigments. To absorb light, photosynthetic organisms use pigments that reflect light of a specific wavelength, and therefore color, and absorb the rest. On Earth, they absorb mostly visible light thanks to a variety of pigments. The most important are porphyrins, simple ring-shaped molecules, extremely stable, with a single metal atom in their center. All green plants use chlorophyll. So if I'm understanding that correctly, each green plant absorbs all light except for green, which gets reflected right into our eyeballs. I think I'm understanding that correctly. So what if life on other planets use different pigments besides the ones that you find in chlorophyll or whatever? Well, we find some examples of this on Earth with different plant colors and algae. If you think about it like that, all of a sudden, all those weird plants on the planet of Pandora don't seem all that crazy. I don't know. I don't really have much more to say about this, and it really could be summed up in one sentence. Hey, what if plants looked different or something? Next, we have War of the Worlds, and I was glad to see this one on the Iceberg because this one has a very special place in my heart. When I was but a wee little lad, I read the Great Illustrated Classics version of this book, and it made an impression. Now, if you aren't familiar, the gist is this. Some aliens from Mars come down to Earth, and they just start wreaking havoc. They're killing people, abducting people, putting them in baskets underneath their massive terrestrial ships, which are called tripods because they have 3 legs. And you could see the Tom Cruise version, which I don't care what anybody says, is a very good movie. Basically, these aliens from Mars are causing some trouble for us. Spoiler alert, in the end, all of the aliens die. And the reason is because of our bacteria and viruses. They can't handle it. They weren't used to it. And to be honest, that makes a lot of sense to me. But different publications like TV, movies, books, and just the illustrations in those books, they are almost all different on what they would look like, but most of the time they're squid-like, and so they have tentacles and whatnot. The interesting thing, one of them, is that they seem to reproduce asexually, so one of them will just bud off and become another one and just generate. And the illustration in the book I read when I was a kid was not pleasant, and so that's one I really remember. But they also have no need to sleep, and they have no digestive system. So how do they eat, you might ask? Well, they abduct people, and they feed on them via blood transfusion, which is what they do when they're on Mars with a species of creature that is very similar to humans. And so they come to Earth, and they find us here, and they're like, hey... You know what I mean? But I do like the idea of them using tentacles because if Mars has lower gravity, maybe they don't need to worry about supporting themselves so much on more sturdy limbs like we might have. In any case, when you make up an alien species from scratch, that is speculative evolution, so War of the Worlds falls right into that. C.M. Koseman, which is the first on this second tier of the iceberg. Have you ever heard of C.M. Koseman? Of course you have. Not only did he write one of the most popular works of speculative evolution, especially recently, it's called All Tomorrows, by the way, he also co-authored All Yesterdays and All Your Yesterdays, and we'll talk about some of those coming up soon, but he also regularly updates his own site with sketches and artwork, and he has created an extremely complex and amazing piece of world building / speculative evolution called Snaiad. I hope I'm pronouncing that right, and that is basically a living, breathing site with works of art that he's created and the community has created and he has accepted as canon. It's interesting, but we're going to talk about that a little bit later as well. And so he's basically a Spec Evo legend, you know what I mean? He's very good at what he does. And he's the artist and brain behind All Tomorrows and just a ton of different stuff that will make up a big part of this iceberg in general. So why is he at tier 2? Well, there are some things about him that you don't know, probably, or at least in some of the works that he's created, but you probably do know about All Tomorrows, so that's coming up in a little bit as well, so whatever. I don't think this iceberg was created as recently as you might have expected because All Tomorrows would be probably higher by now. But anyway, be sure to check out his site and his YouTube channel because he has one right here on youtube.com, and I'll leave a link to those in the description. Next, we have the concept of Panspermia. Now, you may recall from Tier 1 way back then when I referred to this, and it is something that we would talk about. And here we are. It's crazy. But picture, if you will, an asteroid traveling through space. riding on that asteroid are some single-celled organisms, and they're just hanging out. They're just living their best life. Now imagine that a piece of that asteroid breaks off and hurtles towards a planet that has no life developed on it whatsoever. And it collides with, well, let's say Earth, for example, a long time ago. And then let's say that life on Earth just arises from those organisms. Well, that is the concept of panspermia. It's that life didn't arise on Earth, but instead Earth was infected, in quotes, with life from elsewhere in the cosmos. Of course, this opens up a big can of worms. What if that same asteroid gave birth to life on other planets? Would they have evolved similarly or perhaps differently based on their environment? These are the questions that we must ask ourselves with this theory of panspermia. In reality, though, the study of panspermia isn't so concerned with how life, in the hypothetical example of the asteroid and bacteria going to all these different planets, not so concerned with how life might have arisen as a result of that, but it's more concerned with how the mechanisms by which life could have been distributed throughout the universe. So that's, if you're studying panspermia, that's what you're interested in, apparently. So some scientists believe that between 3.8 and 4 billion years ago, Earth was bombarded by a lot of meteor showers. According to them, since life on Earth arose around this time, it only makes sense that what if on one of these meteors that collided with Earth, there was already some life on it, and that is where we got the seed for all life that would come afterwards. To bring the point home even more, there were some strange observations on Halley's Comet, which passed by Earth, and it seemed to indicate that there was maybe some bacteria riding along. Now, I'm not, again, that smart, so I'm not sure what those things were. You can read about it, but Halley's Comet having bacteria on it, maybe, who knows? And that could have been a source of panspermia for some parts of the galaxy. Who knows? And so the question is the universe littered with bacterial spores that could have infected planets and given life all over the galaxy? I don't know. But from the side of speculative evolution, I think it's an extremely interesting concept and one that's worth exploring, especially if you're doing your own bit of world building. And again, those go hand in hand. So next we have the high oxygen world. What a concept. I mean, oxygen is great. I love it. I breathe it every day. And Earth's atmosphere is composed of about 20% oxygen, which is awesome because I love using it to breathe. Higher oxygen, though, like, so for example, if Earth had higher oxygen, we might find that insects would be huge. As it turns out, their size is directly correlated to the amount of oxygen in the atmosphere and how much they can intake. So if you look back in the old fossil record, bugs were big, okay, and it was kind of disturbing. So if we had a lot more oxygen today, then they would be a lot bigger. So that's weird. I wouldn't wish for that personally. We'd also have more wildfires because combustion would be easier in a high oxygen environment. You and me, we'd feel a lot more energetic. We'd be a lot more alert. We'd be able to think faster, move faster. We'd be able to run for a very long time because oxygen would just be so pervasive in our system and it would fuel us. The downside of that, as it turns out, is that higher oxygen leads to faster cell replication. And that might mean that we age faster. So there is a give and take there. Turns out 20% is a good amount. One interesting idea is, would trees be bigger? And in my own research, I've discovered that tree size has more to do with gravity because they have to pump fuel essentially through their circulatory system up into their branches and whatnot. And so they are usually limited by gravity and the ability to do that efficiently, more so than oxygen. But who knows? Maybe we'll come back to the idea of a low gravity world. But anyways, that's the idea of high oxygen. How might it change life? That's speculative evolution as far as I'm concerned. Next is the concept of astrobiology. Now, obviously this is on the iceberg, but I think it's a bit too broad to cover in any detail because here's the definition. Astrobiology, formerly known as exobiology, is an interdisciplinary scientific field that studies the origins, early evolution, distribution, and future of life in the universe. Astrobiology considers the question of whether extraterrestrial life exists, and if it does, how humans can detect it. So you may have noticed that one paragraph sums up everything we've talked about so far. The whole idea of speculative evolution, the idea of panspermia, the idea of conjecture of what other planets may look like, it's all contained in the subject of astrobiology. So it is worth pointing out, though, that this is a true scientific discipline. So it's not just like cryptozoology or something like that. It focuses on determining planetary habitability and communication between planets. You may recall the Drake equation, which we talked about in the last tier. And so that falls well under the umbrella of astrobiology. So it's very interesting. And so if speculative biology interests you, why not explore the field of astrobiology? You might find it very similar and rewarding. But next, we're moving on to dragon biology. Now, as you know, dragons are normally associated with medieval times or fantasy. But what if they actually existed? Do you remember a fake documentary that aired back in 2004 on, I believe, Animal Planet? Because I sure do. First of all, it's a documentary that talks about what if dragons were real. And it was, at least in America, narrated by Sir Patrick Stewart, who really lended a sense of amazing quality to that documentary. I have a way with words. In that documentary, the idea is presented and it's reenacted and everything. In the world of the documentary, some skiers in Romania come across a retreating glacier, and they basically find a cave that was covered up by that glacier for who knows how long. And inside they find the dead and frozen bodies of some medieval people from that era. And they also find a frozen and perfectly preserved body of a dragon, at least what we would call a dragon today. And so the remains of the people around the dragon were burned, and so it's a very interesting concept. And so the rest of the documentary, they're like dissecting this thing and trying to figure out exactly what made it tick, what were the biological ways that it was able to breathe fire and fly and different stuff like that. So the documentary presents the idea that dragons evolved alongside dinosaurs as just a separate branch. How did they breathe fire, you ask? Well, their inner mouth was armor-plated in a way, and they had a valve-like false palate, just like crocodiles do. And so maybe they have a common ancestor, but they release hydrogen from their bodies through their mouth, and then they chew up rocks, specifically platinum, which acts as a catalyst and ignites the hydrogen, and that's how they breathe fire. That's very interesting. Have you ever seen the movie Rain of Fire, which they use two valves in their mouth to create some kind of napalm? It's very interesting to see the ways that different people will make dragons work, and who knows? I sure don't. That's some impressive speculative zoology, let's just say that. And I love that something like that documentary exists because it's just super interesting. I think you can find it on YouTube. That's how I found it anyway. Now, I read an article from the BBC that says that a dragon with 4 limbs and wings, so what we sometimes will see a dragon walking around on 4 legs and it also has wings above them, is extremely unlikely because evolutionarily speaking, it's extremely rare for anything to have more than 4 limbs, and it would just be inefficient for that to have evolved. What is more likely is that the front 4 limbs develop into wings. When that's the case, and you have just back legs and wings basically, then that is not a dragon. That is called a wyvern or a wyvern, something like that. So just want to make that distinction. But that means that they were probably more shaped like pterosaurs, and so they would have to be able to push off the ground, small torsos, small rear legs, and they would need more muscle up in their chest area to help push their 4 limbs off the ground and then start flapping, of course. Most animals that can fly also have hollow bones and different stuff like that. So the idea of a dragon that could actually exist is probably much different than the idea of the dragon that we have in our minds, like from Game of Thrones or something like that. So that's just something to keep in mind. I think it's very, very fascinating. And so there has been a lot of thought that has many smart people have put into how dragons' biology might actually work and what would make them actually exist and function in the real world. So it's a real rabbit hole to go down if you want. I didn't expect to talk so long about this, but it's cool. Now, do you remember earlier in the video when I talked about a little fella called C.M. Koseman? I don't know why I phrased it like that. Well, he wrote a book called All Yesterdays, I briefly mentioned as well. And is this a sequel to All Tomorrows? Nope, it's completely different, but they have similar names. So again, another parallel I didn't need to bring up. Ever since dinosaurs have become popular, which I believe was around the 1800s, humans have wanted to draw them and paint them. Why not? We need to know what they look like. But obviously, as scientific understanding of how these creatures behaved and their form evolved, so have the associated works of art. Now, of course, that artwork has come a long way. They used to be portrayed like just long lizards basically walking around with their tail for support if they were theropods, or, just different stuff like the brontosaur, which people thought had to live in swamps because it was too massive to walk around. And we found out later that is not the case, and it got its name changed. That's a little trivia for you. But I don't care how inaccurate something like Jurassic Park is, that will always be a true dinosaur to me. So anyways, back to All Yesterdays. C.M. Koseman, and then John Conway and Darren Nash, those are the 3 people that authored this book, and they realized that many dinosaur reconstructions are older and inaccurate, outdated. And so what they did is they compiled a book along with original artwork, published it in 2012, and basically their idea was to address some of those discrepancies that they found in these outdated works of art for these dinosaurs. But beyond that, it also presents some speculative possibilities on how these dinosaurs might have not only looked but behaved, and well, we'll get to the rest of it here in a second. That's what makes the book so interesting, is that it takes the idea of these dinosaurs, which we usually see in, like, for example, the Tyrannosaurus and the Triceratops fighting each other, is just perfect for creating a painting. And usually they're in some kind of motion, like a velociraptor attacking a protoceratops, something like that, that we see so often. These guys wanted to make a book where it was just more about the day-to-day life about these dinosaurs. How did they actually behave when they weren't doing something epic that a painter would normally want to paint? For example, check out this picture. It shows an Allosaurus and Camptosaurus. Though they are enemies, they're interacting here in a non-violent nature. The Camptosaurus is just curious, and this sometimes happens in nature. Sometimes the prey will approach the predator on the savannah or something like that, just out of curiosity, and nothing bad happens to either of them. So maybe that happened back in the past. And so this picture just kind of portrays what that might look like. It's very precious, in my opinion. Or check out this Camarasaurus enjoying a roll in the mud, much like a horse might today. Or how about a fat Parasaurolophus? This is another point that the book brings out, by the way. We usually see these creatures designed in a way and utilizing what they call shrink wrapping, which is where they basically just put a thin layer of muscle and skin over the skeleton that we already know exists. That's not all that likely, though, because, you know, animals have fat, muscle in places that you might not expect if you just looked at the skeleton. And so they call it shrink wrapping when they just basically follow the design that the skeleton has with little imagination. But I mean, you can't really put too much into it, and this is where the speculative part comes in. So maybe the Parasaurolophus was much more bulky than we would consider traditional art showing. It only makes sense. This is speculative zoology at its finest, as far as I'm concerned. So at the end of the book, there's this really interesting section, which is, it makes the book for me as far as I'm concerned, but it presents the idea, what if some future scientists were to look back at some of the creatures we have today and only going based on their skeleton, how might they recreate them in their artwork? Using this idea of shrink wrapping that we often see with the skeletons of the dinosaurs from the past, they said, well, maybe the future scientists might reconstruct a cat to look like this. Or maybe hummingbirds are parasites. You know, maybe the future scientist doesn't know. Or how would a future scientist know that an elephant has a trunk, for example? They probably wouldn't, because there's no bones. So the idea behind the book is to get us to rethink our preconceptions about what these animals look like and just have a little more fun with it, you know? And that cat is pretty disturbing, but it just goes to show how much we don't know and how much we have yet to discover. So it's just, I love it. It's really good. It was really well reviewed, and you can actually buy this one on Amazon, unlike a lot of the other books and works we talked about. So I'll leave a link to that in the description if you're interested. It's well worth a read. Next is the concept of the radial body plan. Now, this is on here, I assume, because we want to think about how some alien life might have evolved to have a radial body plan, which we're not used to, because humans or most animals that we're familiar with have what we call bilateral symmetry. And so for basically every left arm, there's a right arm. For every left eye, there's a right eye, you know. We're basically the same on one half as we are at the other, so that's bilateral symmetry. But some creatures instead have radial symmetry, as it's called, and that would be something like a starfish, which has 5 central arms around a central mouth. And so that's radial symmetry. But what if there were intelligent beings, kind of like humans, that had radial symmetry, the similar body plans? Well, I discovered that H.P. Lovecraft himself, the master of horror, described his elder things as having radial symmetry. They had these creatures, the elder things, they had a whole civilization on Earth long before we got here. And they basically just have 5 of everything: 5 eyes, 5 mouths, 5 wings, and, you know, just everything. So it opens up a lot of questions. How would they eat? Would they have a central mouth, or would they have multiple, like a starfish versus the elder thing? Would they have an upper set of 5 limbs and a lower set of 5 limbs? The lower set being for locomotion and the upper set being like grasping limbs like we have? I don't know, but that's an interesting thought. So try thinking of a radial body plan for a human, and it gets weird real quick, but, you know, that is what speculative evolution is all about. Next, we have the idea of alternate blood color. And as you may know, human blood appears red because of hemoglobin, which carries oxygen. And apparently it's a very efficient carrier, by the way, one of the best carriers of oxygen in the world. But what if other beings in the universe did not have similar blood? Would it be different colors? Well, we already have an example on Earth. Octopuses, or octopi, octopodes if you're Greek, they have blue blood because the oxygen carrier in their blood, you want to know what it is? Well, I'll tell you. It's not hemoglobin. It's something called hemocyanin. I, again, don't know if I'm pronouncing that right, but it's pretty cool. It's blue. So what if some humanoid alien on another planet had skin similar to ours, but had blue blood? Or, another color. But blue is interesting because, for example, does their blood use a different oxygen transport mechanism? Or do they even use oxygen for energy at all? That's a question to ask. And so if they get punched in the face, if they have a different color blood, what color is their bruise? And if they blush because you said something risque, what color does their face turn? These are the big questions that we must ask ourselves. Spock, for example, has green blood. And, he's a character from Star Trek, by the way. Could it be that his blood uses another oxygen transport system called chromogen, which isn't nearly as efficient as hemoglobin? Did I read into this maybe a little too much for my own good? Yes, but who knows? Nobody really knows. But ultimately, the different color blood might change the way that they look. And so bruising, blushing might be different. And they might have just dark veins running through their body that we can see if their skin is a little more on the translucent side. Yeah, there's a lot to think about here, but we're going to move on. And that is to something called The Future is Wild. And I will spoil this for you and tell you that I'll be doing a video on this soon-ish, but The Future is Wild is a documentary. It was released in 2003, and it was also an accompanying book called The Future is Wild. I don't know if that makes sense, but the book was written by Dougal Dixon, who wrote the Afterman trilogy, for example, Man After Man, which a video is already on my channel about. But there is a lot of CGI in this documentary, which is how I saw it. I've been so interested in Spec Evo long before it was cool, so you could say I'm something of a hipster in that regard. But anyway, the documentary has a lot of speculation as well, and it's fascinating. They come at it with these creature designs using the input of multiple scientists who are experts, of course, in their field. And the documentary covers 3 eras: 5 million years from now, 100 million years from now, and 200 million years from now. And it also covers many different biomes like tundra, rainforest, ocean, others, and it's super interesting. You should definitely check it out, whether it's the book and or the documentary, which I think you can find the documentary on YouTube. Not 100% sure how legal it is, copyright and all that, but it's out there, so definitely check it out, and it's pretty darn interesting. In the documentary, eventually all mammals go extinct, and in fact the only type of life that remains on Earth are mollusks, insects, slime molds, plants, fish, and crustaceans. I don't know, that's just a super interesting take, like the idea that the dominant life forms are not normally what we would consider to be the most dominant types of animals, at least not right now. You get the idea. My favorite from the documentary is something called the squibin, which is basically the smart, that word cracked me up, which is basically a smart, very smart creature, and it's the smartest creature on the planet, and it jumps around in the treetops. How cool would that be? Now let me ask you a question. Have you ever seen My Octopus Teacher? It's a documentary on Netflix. That thing wrecked me, and so maybe that's why the squibin seems so cool to me. I mean, octopuses are pretty cool too, so we don't need to go that far into the future to appreciate what we have now, do we? Man, that is existential. But also cool in the documentary is something called the death bottle, which is a carnivorous plant that's basically the sarlacc from Star Wars. So that is a big yikes coming from me. I won't spend too much more time on that one because I will be coming out with a video soon. Hopefully. Now, next we have After Man. Wow, this is crazy. I just mentioned Dougal Dixon, and here we are. This is a zoology of the future, and it's basically, again, written by Dougal Dixon and published in 1981. It is a field guide, as far as I'm concerned, for future animals. The whole book is set 50 million years in the future. That's like my 10th take on that for some reason. And Earth has changed quite a bit. There are a lot of species in the book, like over 100, so I can't really talk about them all, but I'm gonna pick out some highlights here because it's super interesting. This guy's pretty creative, but he bases everything in science, more or less. He's a scientist by profession, so it's pretty interesting. For example, the rabucks, which basically with all these animals that we know today going extinct, these new ones have to take their ecological niches, basically just run the world where they used to. One of those is the rabuck, which fill the deer, zebras, and antelope niches. Then there's the gigantelopes, which are future antelopes, and they fill the niches that elephants, moose, and rhinos used to fill. And then you have vortexes and porpoise, great names, and these are both descended from penguins, and they fill the whale and dolphin niches in the ocean. Now, you may be wondering who takes the place of the bears and the wolves and the big-time predators, the big cats that we love and know today. Well, Rats do that. And so this is what they look like. And it is a disturbing concept, but they have changed a lot. So it's not as bad as it could be. I mean, if you're a fan of rats, absolutely. I am too. Some people get creeped out by them. I'm not one of those people. Next, we have raboons. They're basically like baboon raptors. Dinosaurs. They walk on their back legs. They look like theropods. It's very interesting, but this is an example, if we go back to tier 1, of convergent evolution. So how about that? And then we have night stalkers, which are the terrifying descendants of bats. This is the wackiest one as far as I'm concerned, but hey, it's in there. I will say that who loved this book and everything that Dougal Dixon does is the Japanese market. And they loved it so much that they made an anime based on this, and they also made a stop motion movie. And it's a fever dream. Let's just say that. It's hard to find. I think the documentary is on YouTube, but I don't know how you'd find the anime. If anybody knows, let me know, because I would love to watch it. The book itself makes a fantastic piece on your coffee table because it's mostly art. Well, it's primarily artwork. That's the focus, I guess, but it's like a field guide, so there's a lot of detail in there. As you may know if you've read Afterman or seen my video on it, it definitely takes a more biological approach than science fiction. So I'll leave a link to that in the description as well if you want to check it out and buy one for yourself. It's extremely entertaining and definitely one of my favorites. Next, we have the concept of low-gravity planets. I alluded to this in an earlier part of an earlier video, but have you ever seen the movie John Carter? Well, no one has, so I'm not surprised, but they jump around and they do big jumps because there's low gravity on Mars. And so, wow, it turns out John Carter can jump really high. So that's a big pivotal moment in that movie for some reason. But is that likely on Mars? I don't know. I'm no scientist, but it has lower gravity, so maybe. There are some interesting thoughts that come up when we imagine a planet that has lower gravity. For example, people might develop longer limbs and more delicate bones. Maybe you recall the Striders from All Tomorrows. Those guys lived on a low-gravity planet until the chickens came and killed them all. Maybe that would be a result. Maybe we would have taller trees. As I mentioned before, trees are usually limited by gravity because of their circulatory systems, but maybe if there were low gravity, they could grow much higher, and maybe this is paired with a high oxygen environment, and trees would go crazy. I don't know. We would find on a low-gravity planet that we couldn't run as fast because momentum would be less, I'm guessing, but we'd also see bigger flying animals, and animals that we wouldn't normally associate with flying would be able to fly. For example, maybe there would be some huge bats or maybe some huge birds. Bottom line, muscle-powered flight would be much easier. And what if with this lower gravity, there was high air pressure? We would see no fall damage. That would be pretty cool. So there's a lot of cool things that could happen with a low-gravity planet, and all of it is speculative. Now, this one, Space Whales, is on here, and I gotta say, when I was younger, there was a little-known Disney movie that came out. You may have heard of it. It was called Treasure Planet. Honestly, between that movie and Titan AE, I was getting my fill of animated sci-fi. I love both of those movies. But I remember there was a scene in Treasure Planet where they're just taking off for the first time. There's this big sense of wonder, and they come across this pod of whale-like animals just swimming through space. And these were space whales. It turns out they have a name, I found out, and it's called Orcus galacticus, which is awesome. It's a cool scene, honestly. It stuck in my mind for a long time, and I found it, again, just in the research of this, and it holds up, let's just say that. To be honest, the whole movie's underrated. You should definitely check that one out. But the idea of space whales or sky whales is pretty fanciful, I'm not going to lie, but it also is, it's just cool to think about. Just imagine looking up and seeing a whale. We see this a lot in artwork, and especially in the 90s, I remember seeing a lot of it. But anyway, there's even an SCP, if you may be familiar with that line of fiction. 2146 is a frozen space whale that just goes around in Earth's orbit, and it broadcasts a radio signal. I won't say more about it. And then there's another SCP of a blue whale that lives in Earth's lower atmosphere, or at least it seems to, and that is SCP-1608. So the idea is out there, let's just say that. Unfortunately, the idea of a space whale doesn't make much sense because whales' movements are based on an environment that has friction, which is water. And that wouldn't work in space or the sky because there is no friction there. So I guess it's just the idea of an organism moving gracefully through space, and we can just see it. I don't know. That's cool, but I don't necessarily see how that's speculative evolution because that is I mean, it is, okay, whatever. I'm moving on. Next is the idea of non-humanoid aliens. We've already talked quite a bit about different type of aliens that could exist, and that's pretty much everything that's on speculative evolution that doesn't look like a person. It's extremely likely to say what aliens would look like and what body plan they would adopt. It might be radial, it might be bilateral symmetry, we discussed that as well. So, Altomaro's expedition, Snaiad, all those ones I mentioned, they go all in on the idea of non-humanoid aliens, and I think that is more interesting, or at least can be, than the concept of one that's humanoid. But, who knows? But that's all I have to say about that one. It's pretty self-explanatory. Now, this one is not on the original image, but I thought that this should go on here somewhere, and it is the concept of mermaids, okay? I guess most people disagree that the idea of mermaids is speculative evolution because maybe they're more like fantasy or something like that. But as you might have guessed, my childhood was very heavily shaped by documentaries, and one of them that aired on Animal Planet, as I recall, was one called Mermaids, The Body Found. And it was, again, a fake documentary that they presented when they were just crazy with this stuff that said that maybe mermaids are real. And they had all this found footage and stuff like that. Anyway, the idea behind that documentary was that these mermaids were just aquatic apes. And so at some point in humans' history, there was an ancestor that, evolved into people, and one that split off and went back to the water. So they were just aquatic apes, basically. So, they developed webbed hands and eyes that could see better underwater, and then their lower limbs fused together. So this is what we see as mermaids now. To me, that's speculative evolution. Let me know if I'm wrong, but it's super interesting. But then there's the idea, who's to say that mermaids are apes at all, H.P. Lovecraft himself, the master, he has something called the Gnori, or just Nori. I don't know how to pronounce that one either, but that is a creature that has 2 to 4 arms on its upper torso, and it has a weird tentacle as a tail for a lower half. They also have beards, so... Anyways, you can still check out that documentary, by the way. Mermaids, The Body Found, I think is on Amazon, so check that one out. So let's just jump right in with tier 3 here. This is Alien Planet and Expedition. Now, these are combined because they're basically the same thing. But as an introduction, let me just say that I'm probably starting to sound like a bit of a broken record because Alien Planet was one of those documentaries that I just loved as a child and has really cemented my love of science and all that different stuff. I remember sneaking out at my grandparents' house, out of my bedroom when everyone was asleep, going in there and just watching it, just having the time of my life. I guess that's what you could call my rebellious phase, was sneaking out and watching documentaries. Anyway, now, okay, so Alien Planet is the documentary, which is based on a book called Expedition, and that book was written in 1990 by a guy named Wayne Barlow. He is a concept artist and a science fiction author. Very, very good, by the way. I definitely recommend checking out any of his work, Wayne Barlow. But actually, the full name of the book is Expedition, being an account in words and artwork of the 2358 AD voyage to Darwin 4. So that's kind of a mouthful, so I won't be referring to it in that capacity anymore. But Barlow wrote it because, as he put it, he was dissatisfied with the common science fiction trope of alien life being similar to life on Earth, especially the notion of humanoid intelligent aliens, which, if you saw the last part of my video, I definitely identify with because I always did wonder. But for him, it was worth creating a whole book, so definitely acted on it differently than I did. So basically, the idea between both the documentary and the book is that the year is 2358, and in the text, Barlow travels to Darwin 4, which is a distant planet found teeming with life. Yes, if you're asking, it's Barlow himself in the book that travels to Darwin 4, and he sees everything firsthand. He takes notes, and the sketchings and drawings that he makes are from firsthand experience. In the documentary, which aired, I believe, on Animal Planet or something similar, Discovery, it's 2 what are known as Horus probes that go out there, and they report back to Earth, kind of like we've done with the Mars rovers and stuff like that. I always thought that those 2 robots were super cool. Their names are Leo and Ike, which is just precious. Now, the documentary is kind of cool because it features prominent scientists, which you may have heard of: Stephen Hawking, ring a bell. Jack Horner, famous paleontologist who consulted on Jurassic Park, the best movie of all time, and even George Lucas himself makes an appearance, which, I mean, that's fine. So while the documentary is pretty cool, and I used to love it, I mean, I still do, but I used to too. So what kind of things does it feature? Well, one of my favorites from both the documentary and the book is called the Arrow Tongue, which is kind of like a weird T-Rex. It stands 26 feet tall, or 8 meters, which is big, in case you were wondering, and it has this kind of like harpoon tongue. Here's what it does. It's what's known as a liquivorous predator, which is a really cool word that I didn't know until I started researching this, meaning that once it reaches out with that harpoon-like tongue, stabs its prey, incapacitates them a little bit, it starts injecting digestive enzymes into them. Then it just stands around, it waits, and then once the animal's completely liquefied, it just starts drinking it. Now, the idea of a liquivorous predator isn't too far-fetched. On Earth, we have spiders, which do the same thing, and that's just imagine if that spider was 26 feet tall. Just imagine it. Another really cool one that I like is called the groveback, and part of that is because it just has this sense of awe about it. So it's tripedal, which is unique. And it looks kind of like a turtle, but much, much larger. Now, what's really cool about this is just the idea of seeing one of these in real life. It's nocturnal, so it only comes out at night. It's wandering around its world. It's completely dark. But just imagine you're standing there, and rather than seeing it, you start to feel it. You start to feel the ground shake and the earth tremble. You hear this extremely loud, even at a distance, scraping sound. No idea where that's coming from. But if you were to find it, you'd see this giant creature just pulling itself along the plains. That's because it has this rear skid, so it's tripedal, but the back limb, if you want to call it that, is immobile. It just pulls itself along on this skid, which unearths all these different creatures and plants and whatever else might be, but that's what's producing such a loud sound. The arrow tongues actually wander around with it, and they're scurrying around its legs and stuff because everything that it overturns, it starts uncovering prey, and the arrow tongues will eat it. So there's this kind of relationship between them. It has trees on its back because why not? And here's how it feeds. It's kind of like a land whale because it feeds by inhaling airborne animals. And so just imagine seeing that thing walking around, breathing in animals, scraping along, surrounded by these fierce predators. That's a cool image to me. There are a lot of really, really cool animals in Expedition, and I've already spent a lot of time on it because it's so cool, but I'll just have to tell you, check out the documentary, get the book. You can buy it on Amazon. I'll leave a link to both in the description. Next, we have alternative DNA. Now, as you may recall from school, the mitochondria is the powerhouse of the cell. And of course, that has nothing to do with this section of the iceberg, but I just wanted to refresh your memory a little bit. But what is important is DNA. And what does that stand for? Well, say it with me. It's deoxyribonucleic acid. And as you also know, DNA is where the body's or organism's genetic material is stored. The question that this section of the iceberg presents is, what if there were different types of nucleic acids, the building blocks for DNA? Well, as it turns out, scientists have discovered at least 6 nucleic acid analogs, as they're called, and they're very comparable to DNAs. And this is very interesting because it gave birth to a whole new set of terminology. So instead of DNA, a deoxyribonucleic acid, we have xenonucleic acids, which give us the wonderful acronym of XNA. Now, the xeno in xenonucleic acids doesn't necessarily refer to like alien life or alien nucleic acids in so much that it means extraterrestrial. Instead, it's biology that's alien to us. So it may have never existed before we created it. And that's exactly the way it is with XNA. It's essentially synthetic DNA, which is just a wild thought. So these scientists have figured out a way to use different sugars other than what DNA does, and have created synthetic strands of genetic storage. And here's the big part. Through replication, the information that's stored on these synthetic strands can be passed down from generation to generation, which is just crazy. So how might this be useful? You might be asking yourself. Well, for one thing, if you've ever wanted to play God, apparently this is a great field to get into because anyways, but this leads right into my next thought, which is the idea of xenobiology. So the study of XNA and everything, that kind of folds into this field, xenobiology, and that's the next part of the iceberg. Have you ever seen a sci-fi film like The Fly or Splice, the lesser known, or Jurassic Park, the best film ever made? Well, maybe after you watch one of those movies, you thought to yourself, yeah, sure, genetically modified life is cool, but it's just not enough. Well, my friend, let me introduce you to the topic of xenobiology, which I already alluded to. In short, it's the idea of creating life from elements that never before existed. So if that sounds interesting, just buckle up. It is directly related to what we spoke about earlier with the XNA. In fact, it was the study and discovery of XNA that kind of gave birth to this particular field in general. Now, of course, there is way too much in the field of xenobiology to cover in a single video, unfortunately, but we're gonna summarize it here. Basically, one of the goals of xenobiology, and this is crazy, is to rewrite the genetic code. So if you're not familiar, the genetic code is basically the set of rules used by living cells to translate information encoded within genetic material like DNA into proteins. And so that's the goal of DNA, basically. And that's what the genetic material does. So the genetic code can be divided up into 3 sets of nucleotides called codons. So keep that in mind, codons. So xenobiology, and as a result, XNA, seeks to implement unused or new codons, so new sets of nucleotides. So that's cool and all, but how does it actually work, you might be asking? Well, we have an example because in 2013, a guy named Farron Isaacs and George Church, 2 gentlemen over at Harvard University, reported that they had replaced all of the stop codons, as they're known, in the genome of E. coli with synonymous TAA codons. So wherever certain ones called stop codons appeared in the genome of E. coli, they were able to replace with foreign codons that were previously unknown to that particular organism's genetic code. It did this throughout the genome, so following the success of that genome-wide codon replacement, as it's known, the authors continued and achieved the reprogramming of 13 codons throughout the genome and directly affected 42 essential genes. Now, a lot of that is straight from Wikipedia because I'm not all that smart, but I'm getting a handle on it, and hopefully it makes sense because basically what they're doing is manipulating the genetic code with codons, nucleotides that had never been before seen. That's crazy to me, just the idea that we can actually do that. Or not we, of course. I had nothing to do with it, but it has a ton of applications. For example, we could create life that is resistant to disease. It may not be very complex, but I mean, that's crazy to think about. Hopefully it doesn't lead down the path that All Tomorrows tells us about. But what if there was other manipulations based on different genetic materials, like XNA? Crazy. All right, so we talked about some pretty intense stuff just then, as far as I'm concerned, but let's go ahead and back it up a little bit, bring it down a little bit smaller to a section called The New Dinosaurs. This is a book written by our good old friend, Dougal Dixon. It was written in 1988, but unlike his other books, After Man or Man After Man, this book is not set in the future. Instead, it asks the question, what if the dinosaurs hadn't gone extinct? What would they look like now? To me, that's a pretty interesting question. The question posed by the book is, how might evolution have changed what we perceive in the past if they hadn't gone extinct? They would have had to live through things like the Ice Age and, continental isolation, different stuff that they never had the chance to. And so one thing's for sure, in the presentation that Dougal Dixon gives, mammals did not take over. Dinosaurs remained essentially the dominant life form on our planet. Now, to get more specific, the most successful group of dinosaurs in the modern era, according to this book, are the Silurians, which include, buckle up, Compsognathids, Tyrannosaurs, Ornithomimosaurs, and Maniraptorans. So, do I need to say more? I think I will. Maniraptora, which is the last one, that is a group of creatures that includes birds. And according to a guy named Backer, as I remember the quote being from Jurassic Park, those are the only group of dinosaurs alive today. So what does that look like? Well, for example, check out this tundra-dwelling species called the mountain leaper. It's a dinosaur that became endothermic, which means warm-blooded. It has lots of fur, and it's 3 feet tall. It travels in small packs, so it's kind of like that image that we have of small raptors running around. But this one's warm-blooded and it's adapted to cold climates, so that's kind of cool. Speaking of cold climates, how about the balaclav? Balaclav. Well, it lives in the mountains, and it's a descendant of what are known as the Hypsilophodons. So just check out those layers of fat. Can you imagine getting cold with that much fat? Impossible. And then check out that beak. Whew. Another interesting one that I like is the Sprintosaurus, very aptly named. It came from the duck-billed dinosaurs, and it walks around mostly on 4 legs. It lives out in the prairies, and it has these crests on its head that you may recall reminiscent of some of the hadrosaurs like Parasaurolophus. And in Dougal Dixon's books, it is confirmed that those crests are used as sounding tubes, so that's kind of interesting. So much like his other books, The New Dinosaurs, it reads a lot like a textbook. It's very educational, and that was the intent. The art is what I would call utilitarian. It gets the job done, but without a lot of, flashiness or style, I guess you could say. But that's the idea, so it's pretty cool. And all the creatures in it are fascinating. I would definitely check it out, especially if dinosaurs are your thing. Next is the idea of silicon-based life. Now, what I mean when I say carbon-based is that a chain of carbon and oxygen, or whatever it might be, create molecules that are stable and long strong enough in order to support complex organisms. And that's why we see carbon as such an important part of everything on Earth, basically. But what if instead of carbon we used silicon? Is that even possible? Well, potentially. In fact, it's, I guess you could say, one of the most likely scenarios if we were to find an alien race or something that didn't use carbon as its most basic building block. It would probably be silicon. And that's because it's close to carbon in the periodic table. It has a valency of 4, the same as carbon. And because of that, each atom could, in principle, form bonds with up to 4 other atoms, just like carbon, and could also therefore be a building block. So in theory, it could produce similar structures and different stuff like that. It's also pretty widely available. You can find it all over the universe and even on Earth. Problem is, whereas the product of carbon's oxidation, if I'm saying that right, is CO2, it's carbon dioxide, the waste product of silicon, instead of being a gas like carbon dioxide, it's a solid. It's non-soluble until more than 1600 degrees Celsius. So we have the advantage of being able to exhale carbon dioxide. It just mingles with the atmosphere. It's gone. We're good. Silicon dioxide, unfortunately, unless you were on a planet that was extremely hot, you'd give off a material that is solid. That could be an issue. Similarly, silicon is inert until those very high temperatures are achieved. So that means that any life form that was silicon based would probably either need to be on a planet with extremely high temperatures, which would make visiting that planet difficult for humans. If it did exist, that life would probably be very slow moving. Energy would have to be stored in a different way. There's a lot of conjecture that goes into this, of course, speculation, if you will, but life forms like that might be like living rocks or blobs, you know? Now, if you want to deep dive into this by somebody who understands science, unfortunately, far better than I do, for me anyway, Isaac Arthur is a great one to check out. I'll leave a link to him in the description, or his video specifically on silicon-based life. It's very interesting. So I would definitely recommend checking that out. But is it possible? Yes. Is it likely? It's hard to say unless the conditions were just right. Next, we have Furahan Biology and Allied Matters. Now, I hope I'm pronouncing that right, but we'll come back to that in a second. What is it? Well, since 2007, a guy named Gert van Dijk has been writing a hard science fiction blog, and that's what it's called, Furahan Biology and Allied Matters. I don't think I can describe it any better than Gizmodo did, which they called it a treasure trove of biogeekery. Now, I would consider that to be very high praise. Basically, it deals with an extremely detailed and realistic ecosystem on the imaginary planet called Furaha. Now, am I pronouncing Furaha exactly right? I'm not sure, but if it's based on the Swahili word for happiness or joy, then I think I am. If it's not, it could be just a made-up word. It might be Furahan, but whatever it's called, it's an incredible resource of learning, and a flabbergasting amount of thought and detail have gone into these projects. So, for example, one speculative life form from the planet of Furaha, it really caught my eye. It's called the Bolant. And there's this whole idea of a floating organism. For example, here's an ant holding a bubble between its legs, and it uses that to float around, and it can get from place to place. But here's what's really interesting about the author of the Furahan Biology. It never stops just at the design, right? So you might see some speculative evolution projects where, yeah, that's a pretty interesting animal, but it goes a lot deeper than that. For example, talking about the Bolant, the author also covers the mathematics of how this might work, which is crazy to me. The equation he gives is lift equals air mass minus bubble film mass minus hydrogen mass. So you have to consider a lot of different things when it comes to a floating organism, and the author has done it. There's a lot more detail there. I'll leave a link in the description, as I always do. But another option for a floating Bolant, if you will, might be a bubble, in quotes, formed out of black graphene, which is an extremely lightweight and relatively strong material. And it's natural, of course. And an example of a creature that's been designed that uses this is the floating mantis, which is a cool name. Organs on the abdomen produce the graphene and hydrogen to fill it. Or another interesting one is the marble bill, which is a very large arboreal carnivore with some pronounced specializations. Basically, there's a beak for a mouth. It has arms 3 times the length of its body, which end in hooks, not hands. And it uses 4 feet that it has to grab prey. It's about as big as a person, so it's a pretty big creature. And man, just imagine seeing this thing swinging along. I just like the idea of limbs that end in just hooks, and it's very specialized for that purpose. And just like with a lot of different things, I could literally spend an entire video talking about all the different stuff. It's a huge rabbit hole to go down. There's a lot of really cool stuff on that I would definitely recommend checking out, which I will leave a link to in the description, so go ahead and do that. Next is a documentary called The Natural History of an Alien. This one aired in 1988, and it was also called Anatomy of an Alien in the US, I believe. This documentary features a ton of scientists, including Dougal Dixon himself. Now that's really cool. If you want to see what he's like, this is the documentary for you. So the documentary is really interesting. It's a lot of speculative evolution, of course, speculative biology, I should say. But it starts out looking back in time to find some really crazy looking alien-like almost animals that appear that way to us anyway. And one of them is Anomolocarid, which is kind of freaky, but it spends a little bit of time showing what that looks like. And I mean, if you weren't familiar with it beforehand, like I wasn't, and you just saw this thing swimming around, it seems like it could be a good example of speculative biology, but no, we found fossils, okay? The documentary also discusses the idea that the most likely place to find life other than Earth in our solar system is the moon, Europa, which could possibly have an ocean under a layer of ice. If life exists on Europa, then what would it look like? Well, the documentary says that there could be a whole ecosystem under that ocean that's based around hydrothermal vents, just like the deep sea vents we have on Earth. The documentary also covers a lot of stuff that we've already talked about on this iceberg, like the idea of high gravity planets and low gravity planets, what that might look like. Overall, it has less to do with individual species like Expedition does, and more to do with how might life change based on different environments and where life might be found. So it has less to do with individual species and more about the big picture. It's a big picture kind of documentary. I will say that the animation is a little outdated. It can be kind of freaky sometimes, I'm not going to lie. But it's fun to watch because it's like a relic of another time. This was the time before we had all the best CG in the world. Of course, that's true of anything pre-1990 or something. But, it's just interesting to see, as with anything else we've talked about, the scientists' ideas of what an alien planet might look like. And this is a great example. And then at the end, there's a clip from a dude who really doesn't think that the idea of humanoid aliens is plausible. So next, we have a work that needs no introduction. It's All Tomorrows. I don't have to tell you about All Tomorrows. It's been blowing up lately, okay? But, as I mentioned before, if this iceberg had been created maybe a little more recently, then this would be a little bit on a higher tier, like number one, because it's so popular. But in being faithful to the source material, I'm going to leave it right here on this tier. That's where it belongs. In any case, if you haven't heard about it, or you don't know what it is, or you just want a refresher, I have another video that I sort of talk about it, but here's a brief overview. All Tomorrows, it's an ebook written and illustrated by our good friend C.M. Koseman under the pen name of Nemo Ramjet. It's actually called All Tomorrows, a billion-year chronicle of the myriad species and varying fortunes of man. So how's that for a title? Almost as good as Expedition. So quick summary is that in the near future, humans colonize Mars. Eventually, there's a civil war between us on Earth and our Martian relatives, and fortunately, it ends up being a peaceful resolution after a lot of people die. We genetically modify ourselves to become super intelligent, and we spread across the galaxy, and we colonize it. Then, some jerks called the Q come along, and they modify the heck out of us in all these different ways, some quite disturbing, but it's all very interesting. And eventually, the only remaining humans are nearly unrecognizable. Eventually, the Q leave. The rest of the book details how these genetically modified humans evolved from there. What I like about All Tomorrows is that it's a story that definitely fits in the realm of sci-fi, so it's a very compelling, interesting story. The illustrations are fantastic, I don't have to tell you, and surreal. And so it's very interesting. It's really become the quintessential work of modern speculative evolution. And so again, I'll leave a link to the description where you can read it for yourself because it's free online. And you can also check out my video on the subject. Just saying. Next, we have Life on Mars, scary version, as it's called. Don't be afraid, okay? You don't need to click away because it says the scary version. Just bear with me, okay? Back in the 1950s, Walt Disney aired a show, and it was called Walt Disney's Disneyland, which is a great name for a show as far as I'm concerned. It aired from 1954 to 1958. It was one of those kind of anthology TV shows. It had different segments every week, so each episode was different and unrelated. And one of those segments, though, that you would see come up fairly often was called Tomorrowland. And it was based on the ride or attraction at Disneyland, but it detailed what the future might look like. And it did that in a lot of different ways. So what kind of cars might we be driving? Where are we living? What kind of homes do we have? Different stuff. And one segment in particular of one particular episode was Life on Mars. And it was a vision of what that life might look like. So speculative biology, here we are. Now, I won't be able to play the whole thing because I am concerned about copyright. It's Disney after all. But the animation on this thing is sublime. You really need to check it out, especially for the era that it was produced. And yeah, okay, sure, it's a bit scary. I'll admit it. It's got this dark tone to it, and it's kind of creepy. Now, it may not be that scary to us today, but I'm sure at the time it was freaky stuff. This was around the same era that people were freaking out over War of the Worlds, the radio broadcast. So basically that. This part of the iceberg is a clip from an old TV show that Disney produced. It's still really interesting, but it's only a few minutes long. Definitely check it out. And it does fit on this iceberg. Yeah, it's speculative zoology, speculative biology, if you will. It's speculative and it's biology. Moving on. Now, next on the list is the idea of crystal life forms. And to be honest with you, I couldn't find too much on this. The problem with a crystal-based life form is that crystal is rigid. And it would be difficult for cell-based life to work because the membranes of cells need to be permeable, flexible, and it's also difficult to imagine a creature that isn't cell-based. So there's a lot of different things that make the idea of a crystal life form difficult as a concept. Of course, alternate forms of life or biology may be able to make this work, I guess, but what would that look like? I mean, I don't know. I guess it would look like a crystal. For a couple of examples of what a crystal-based life form might look like, we can turn to the world of Star Wars. I bet you didn't see that one coming. For example, you have the Vulptex, which is a fox-looking creature from the planet Crate. You may have seen them in The Last Jedi or in the video game Battlefront 2. They're there. Technically, though, these creatures just have crystal fur. They're not really crystal-based. And of course, the word fur is in quotes because it's crystal. But for a truly crystal-based life form, at least in the Star Wars universe, we could look at these shards, which are crystalline and silicon-based. So how's that for a throwback to earlier in the video? These are sentient crystals that grew near hot springs on a planet called Orax, and they communicated with electromagnetic senses, whatever that means. Now, eventually humans found them, which is an interesting story on its own, because how long did it take before they realized that these crystals were actually sentient without being able to communicate? Probably some time. And they offered to put them into robot bodies, which the shards gratefully accepted. And here's what's so crazy. Those crystals inside of robots, they became Jedi, Now that's what I call a glow up, you know what I'm saying? But really the idea of a crystal life form, it really puts the speculative into speculative evolution. So it's extremely unlikely, but who knows? And we're going to jump right into it. Boron-based life. That's the first part of this iceberg. Now, this is something similar, at least a similar concept, but with a much more obscure element, boron. So the question asked is, what if life was based not on carbon, not on silicon, but on boron? Well, first, it's interesting to point out that boron is not very common in the universe at all. And here's what's interesting. It's only formed by a process known as cosmic ray spallation, or spallation, and supernovae. In fact, it only makes up about 0.0001% of the Earth's crust, which is where it's found. And so, it's scarce. Now, of course, that's not to say that the scarcity of a certain element makes it any less likely to be used, but it's just worth pointing out. For example, carbon is much less plentiful than silicon, but carbon just makes sense, okay? So the problem with boron-based life has less to do with its scarcity, which it is a little bit, and more to do with its tendency to form weak bonds with other elements. And so silicon, and especially carbon, are able to form longer chains to make much more complex molecules. Boron would have difficulty forming complex molecules at all, and even then, only if atmospheric conditions were exactly right. It has to be just right for boron. And so if we were to find boron-based life on another planet, it would likely have an ammonia-based atmosphere with a temperature of less than negative 40 degrees Celsius. That's just the most likely scenario for bonds to form on a boron atom. Because it's less likely that boron would form complex molecules and therefore complex life, life that we would find would be likely small and simple. But, who's to say? There honestly hasn't been a lot of theorizing on this topic, as I've discovered. It just doesn't seem to be a very plausible idea, but it's an interesting one. And who says that the fun in speculation is its plausibility? Not me. Next on the list is a single word, Rhinogradentia. Now buckle up, because this one is a wild ride. Back in 1961, a German zoologist named Gerolf Steiner published a book called The Snouters, Form and Life of the Rhinogrades. And of course, that's the English translation. It was published in German, but I won't butcher that pronunciation. So the term for these creatures, which are called the snouters, is Rhinogradentia. That is the group of these creatures, and it literally means nose walkers. And so most people just call them snouters, or at least that's the common name. These mammals are distinguished by what are known as nasarium, which is a structure derived from their nose, and it's been adapted for all sorts of purposes. We're talking fighting, jumping, and walking, which is its most common one. So the author's name is Steiner. He was a zoologist in Germany, but he writes under a fictional persona named Harold Stumpke. And the book is a very detailed account of the order and the individual species themselves, written in a very dry, scholarly tone. So it's not really tongue-in-cheek. It's presented as if it were a legitimate record of these fictional creatures. In the book, Rhinogradentia were a group of animals, as I said before, that were native to an island called Hawaii, which is a small Pacific archipelago comprising 18 islands. So it was originally discovered by Europeans anyway in 1941 when a Swedish explorer stumbled upon it after escaping from a prisoner of war camp in Japan. And so the exact location, who knows? And we'll find out why that is, because that's coming up a little later. But the rhinogrades, or these types of creatures, the snouters, if you will, were the only other mammals on the island besides people, which there were. According to Stumpke, the order's remarkable variety was the natural outcome of evolution acting over millions of years in the remote Hawaii Islands, completely isolated. Basically, these little descendants of a family of shrew-like mammals have noses adapted to almost anything, and here are a couple of my favorites. You got the Tyrannonasus imperator, which is just the coolest name by far. Basically, their nose, it's tentacles on their face. They have 4 of them, and it has a venomous claw on its tail. It uses these different appendages, the 4 nasaria, as they're known, on the front of its face to walk around, and that's just how it gets from place to place. This is only one example of hundreds of species that the author describes, and it's pretty impressive. Another one is the earwing. It can fly with big ears like Dumbo or something, okay? But instead of flying forwards, it flies backwards, and it uses its nasarium to steer itself through the air. Interesting, isn't it? Its back legs are vestigial. It doesn't use them, and it uses its front legs only for grasping because it flies everywhere it needs to go. And its nasarium has bones in it that allow it to flex. It's just, man, super interesting stuff, okay? Now, you might be asking yourself, why can't we just go visit this archipelago, this beautiful diversity of these snouters, and see them in action? Well, that's because in the late 1950s, nearby nuclear weapons test by the United States military destroyed all of the islands in that entire archipelago. We lost all of the snouters. All of the native inhabitants were already dead thanks to the fact that we introduced head colds and they couldn't handle it. Understandable, very sad. And then all of the researchers of this entire group of mammals were gathered on the island for a conference, and so they died as well. The only surviving record of this entire group of animals comes in the form of this book, which the fictional author had sent to his illustrator, which was the real author. This thing became so popular just after it was published, and even today, that there have been 3 species of animals named for either the author or the group Rhinogradentia. And so it's really made an impact on the scientific community. Speculative biology at its finest. I love it. Next, we have the filter-feeding Anomolocarid. And at first, I thought this has got to be something really niche. I have no idea what this is talking about. And to be honest, I guess I still don't know exactly what the author was talking about. Maybe if he's watching this, he can let us know. But I do have a strong suspicion that he's referring to what I'm about to talk about. So without further ado, remember in Tier 3 when I mentioned one of the cool creatures from Natural History of an Alien, and it was called Anomolocarid? Well, guess what? He's coming back into play again, so this is pretty wild. Pronunciation is not my strong point, but I'm going to go with Anomolocarid, okay? I'm going to stick with that. So if you recall, or if you watched that segment of Natural History of an Alien, you may recall that Anomolocarid had these very specialized appendages right on the front of its face, and, scientists assumed that it used those to grab prey, rip it apart, and then shove it into its mouth. That's what it was used for, much like our arms, Now, I will point out real quick as a side note that Anomolocarid itself was one genus in a larger group of arthropod precursors. That's a cool word. And that group was called Anomolocarid. So that's important. Just keep that in mind. A few years ago, there was an artist named John Mazaros, and he saw these 2 front appendages on the front of Anomolocarid, and he said to himself, hey, what if those weren't used for ripping and tearing, but instead were used for filter feeding? Okay. And so he created this image, and this is what he thought that it looked like, or that it could have looked like. Here's a quote from him. He said, "I drew an Anomolocarid where the great appendages have these long hairs on them, kind of like the baleen of a whale, and I imagine them gliding through the ocean, scooping up plankton along the way." So he then submitted this artwork to a project called All Your Yesterdays, which itself has a place on this iceberg. We'll come back to that later. So he submitted that, and then here is where things get a little bit crazy. Soon after that artwork was published in All Your Yesterdays, scientists found this fossil in Greenland, and it shows a previously undiscovered Anomolocarid with many small spines on its front appendages. It was a filter feeder dubbed Themsiocaris borealis, and one of the researchers on that project found Mazaris's image, and they named the fossil's family Cetiocharidae after the name that he had made up for this, what had been a fictional, imaginary creature. Sadly, the family name was not valid according to the rigorously strict International Code of Zoological Nomenclature, also known as the International Code of Zoological Buzzkills. And it's because, as no real genus named Cetiocharis exists, in 2019 it was formally replaced by the name Themsiocharidae. How's that for a word that I butchered? And you have to admit that's pretty cool. So let's just sum it up. This guy created a work of art after seeing the fossils for Anomalocaris or something like it, and said, hey, what if those appendages were used for filter feeding rather than tearing and ripping apart prey? And then they find a fossil that backs up that exact statement. He predicted it. He basically predicted it, okay? That would be pretty cool. That's what I think that this section of the iceberg is talking about. Next up, we have the idea of the zoo hypothesis. And if you recall from the first tier of this iceberg, we discussed something called the Fermi Paradox. Well, if you recall, the zoo hypothesis is one possible explanation for that paradox. So if the hypothesis of the Fermi Paradox is, hey, where are all the aliens if we're not alone in the universe? Where are they at? Why haven't they contacted us? Why can't we, see them? Whatever. And so the thesis of the zoo hypothesis is simply this. Aliens have been intentionally avoiding Earth. That's about it. That's pretty much the zoo hypothesis. But the question is, why might they be avoiding us? Well, it's possible that more advanced civilizations don't want to contaminate our planet, either with ideals or actual biological contamination. They may also want to wait to contact us until we reach a certain level of political, technological, or ethical enlightenment, if you will. Or maybe, just maybe, they're experimenting on us. Perhaps the aliens have introduced disasters, extinction events, or supplemented our development in some way that we no longer recall. These are all possibilities, according to the zoo hypothesis. Maybe there's even a huge interplanetary coalition, as they call it, that has agreed to leave Earth alone. So this would be very similar to like observing animals in a zoo, but on a grand scale. Now, even if that is the case and, they've all agreed to not contact Earth, it would be very difficult to actually control that. And so the odds of us still, at least in some form, contacting alien life are still likely if that is the case, which some detractors of the hypothesis have pointed out. But I mean, that's just one flaw. But it doesn't really end there. Closely related is the idea of what's known as galactic quarantine, which states that aliens are intentionally restricting all contact to us and ignoring our efforts at communication. So more than an agreement, they may even be aggressively stopping other planets or life from contacting Earth and restricting our access to life as well. Maybe because humanity is deemed too volatile or something. I don't know. It would certainly explain the Fermi Paradox, and it's actually a pretty popular explanation for it. How it actually plays out is the real question, but, you might be asking yourself, what does this have to do with speculative evolution? And I gotta tell you, I don't know. Next up on our list is Snaiad, another word I hope I'm pronouncing correctly. And it seems that no tier on this iceberg would be complete without some contribution from our friend C.M. Koseman himself. Remember in the first video when I discussed how closely related the ideas of speculative evolution and world building are? Well, Snaiad is the perfect example of that intersection. It's world building at its best, and it's speculative evolution, speculative zoology at its best. And the concept of Snaiad is this. Snaiad is a planet located outside the Milky Way, which we discover in about 300 years' time, and we begin to colonize it. We go there, it's pretty habitable for humanity, and so we set up colonies and stuff. So in that regard, that's the kind of the fictional element of what Snaiad is. But The actual Snaiad in our world is a huge project that C.M. Koseman has undertaken for many, many years, and it has many, many species that are described and drawn by C.M. Koseman himself. It's kind of like this project. People have contributed basically to it. So what's super interesting about the creatures on Snaiad is that they are extremely different from any life that you'll find on Earth. But even in the fact that they are different, they follow their own very unique design language, if you will, to a T. It's very consistent. It's so interesting to see. What is that design that they follow so well, you might ask? So on Earth, most animals that we're familiar with, and also humans, are part of a group of creatures called tetrapods. And tetrapods are a supergroup of animals, creatures that have a spine and that have or have had in some point in their evolution 4 limbs. Okay, so this is important. Tetrapods.
I failed to add this part into the video, but I have to say that most animals on Snaiad are not tetrapods, but instead belong to an entirely new type of life form classification called paratetrapods. How neat is that?
Now, I will mention that Snaiad has a lot of creatures on the planet that are not necessarily in this paratetrapod family group, if you will, which there are a lot of species, but that's the one I'm going to be focusing on for this video. So anyways, with that out of the way, let's describe what these paratetrapods are like. So this is where it gets crazy, okay? These guys have 2 heads, all right? So the first head is most similar to the head you would think of an animal having on Earth, okay? It would be the head that you would think of. And really what that is, it's a modified set of genitalia. And so if the creature has big jaws like some of the predators do, well, they're not jaws per se, they're actually genital sheaths, okay? So that top head, the head on top, if you will, which are technically the genitals, are used for grabbing prey, biting prey, if it's a, or maybe plants, if it's an herbivore, whatever it might be. It grabs whatever food it's going to eat, but it doesn't eat that food. Not with that head anyway, because it has a second head underneath. And that head's only purpose is to swallow food. It leads directly into the digestive system. So to recap, we have a head on top, which is technically its modified genitalia, which is used for grabbing food, holding it down, killing it maybe if it's a predator, but the bottom head is what actually eats and leads into the digestive system. The head on top is still used for reproduction, and so it leads into the reproductive tract. Okay, that's what it's for. So another really, really interesting fact is the paratetrapods on Snaiad have hydraulic muscles. And this is arguably the most interesting part to me. This is fascinating because there's nothing like it anywhere in the universe, that we're aware of. No hydraulic muscles exist on Earth for sure. So how does that work exactly? Well, our fiber-based muscles, they pull. So if you move, if you bend your arm, your biceps are pulling your arm up. If you extend your arm, your triceps are pulling your forearm down. So it's pulling. But hydraulic muscles on Snaiad push. That's how they work. So basically, they have a bunch of almost like segmented water balloons throughout their body, and that pushes against certain joints to move. So these kind of segmented water balloons, they expand and they deflate, or whatever word you might want to use there, but when they expand, they push against each other, and that forces the certain bone of a joint to move. That makes their muscles extremely strong, because they're pushing and inflating with this hydraulic fluid, if you will. So yeah, that's how their hydraulic muscles work. But you may be asking, well, what actually inflates or deflates those fluid-filled muscles? Well, what does that for them is they do have a set of muscles that are fiber-based like ours, and that's what actually contracts the hydraulic muscles, so they work in tandem with each other. I just sneezed. Now, what's interesting about these hydraulic muscles is that the fluid inside also acts as their lymphatic system. So it's really efficient. Now, all of this has been broken down on the website. You can check it out. I'll leave a link, as I always do, in the description, and you can go see their circulatory system, their nervous system. Just everything is thought out extremely well. It's so interesting. But I do want to talk about their skeletons, because their skeletons are not made of calcium like ours are, so they wouldn't want to drink milk for strong bones. Instead, their bones are made of like a carbon mixture, and it's very similar to hardwood. So the bones of the creatures on Snaiad are usually black, brown, or green, and they can catch fire. So it's a lot like wood. If you were to find a skeleton out there, you could gather it up and burn it like firewood. And that's an interesting bit of world building, in my opinion. Somebody needs to write some fiction on Snaiad. I'm just saying. So the world of Snaiad is a huge and super interesting topic. I don't have time to cover everything here because there are groups of creatures. There's herbivores, there's water-based creatures, there's land-based predators. I mean, the list goes on and on. It's a huge, huge thing. Maybe I'll do a video on it soon because it's all so interesting to me. But for now, go ahead and check out the link in the description and read to your heart's delight. It's very interesting. Now, the next one is called One Voice in the Cosmic Fugue. Now, you might be wondering, what does that mean? Well, it's an episode of Cosmos with Carl Sagan, which aired back in the 70s, and that's the title of the episode, One Voice in the Cosmic Fugue. And it basically covers several different topics, and a lot of them have to do with kind of similar content that the rest of the series covers, which is, how things evolved, whatever that might be. This one in particular tells the story of how a crab came to look like a samurai warrior. So that might be worth checking out if you want to know more about that. So it talks about, DNA, just different interesting topics. But at the end, this is where it gets into the speculative evolution part of things. It speculates what life on Jupiter might look like. So this is life that's heavily adapted to a gas giant, obviously, which is what Jupiter is. So it needs to fly, and it needs to do so with extremely low energy requirements because it can't land to recover. Basically, it's just a painting that they present, but it shows kind of these gas-based animals, possibly. It's not really described in detail, and then these predators that go after them. And so it's pretty interesting. It's very obscure bit of speculative evolution, I would say, but that's why it's on this tier of the iceberg. So if you're interested in checking out more of that episode, I'll leave a link in the description. You can watch it for yourself. Next up, we have what's known as the Silurian Hypothesis. Now, this is basically a thought experiment. And here's how it goes. If a technologically advanced species dominated the planet around the time of the dinosaurs, would we have any record of their existence? So imagine, a technologically advanced civilization building cities, building infrastructures like roads, whatever it might be, maybe even building spaceships, who knows? But if they did that and it was so long ago, would any record of their existence remain to this day so that we would even know that they existed? That's another way to say it. Basically the same. I don't know why I did that. And if no trace was left, if we aren't able to obtain a record of their existence, how would we know that that didn't happen? We don't see remnants of an ancient, super advanced technology having lived on Earth, but is it likely that maybe we wouldn't see it? That's the question. The name Silurian comes from a race of reptilian humanoids known as the Silurians, which are from Doctor Who. This thought experiment was originally thought up, if you will, by a guy named Gavin Schmidt at the NASA Goddard Institute for Space Studies in New York City. And also Adam Frank, by the way, at the University of Rochester. The Silurian Hypothesis was the name of an article that they published together back in 2018 in the International Journal of Astrobiology. So that work, the work that they published, has some interesting implications for how we should study Earth and the impact we have on it. That was really the goal behind the paper. The research should also help astrobiologists decide what to look for elsewhere in the universe. With this hypothesis of what we might be looking for or not looking for on Earth, to find a record of an advanced civilization, we can use that, extrapolate that to see what it might look like on an alien planet if we were looking for any remnants there. The fact is, the fraction of life that gets fossilized is very tiny. According to scientists, dinosaurs roamed the Earth for some 180 million years, and yet only a few thousand near-complete specimens exist. So think about that for a second. And as the authors of that paper said, species as short-lived as Homo sapiens, so far anyway, might not be represented in the existing fossil record at all. So the Silurian Hypothesis is basically, what if an alien civilization existed? How would we know they existed, or would we know if they existed? And the answer is we probably wouldn't. So that's an interesting idea to think about. Next on our list is the concept of the bioship. Now, Webster's dictionary defines bioship as a type of spacecraft or starship described in science fiction as either predominantly or totally composed of biological components rather than being constructed from manufactured materials. Just kidding. That is actually Wikipedia. It's not a term in the Webster's Dictionary. But basically, a bioship is a living organism that resembles what we might think of as a spacecraft. But unlike mechanical ships, they often regenerate or heal damaged parts because they're, living tissue. And some bioships, at least what we've seen in fictional accounts, are intelligent, sentient, sapient, if you will. The idea of a bioship, as I mentioned from fiction, it exists elsewhere. There's actually quite a few books that talk about the idea of bioships, one of them being Star Trek Voyager. But I would say that one of the best examples of a bioship comes from relatively little known sci-fi series called Farscape. And that is just a gem of a series from way back in the day. A couple couple of my friends owned the entire VHS series, and boy, did we have some fun. So in that series, bioships were called Leviathans, and they were sentient beings that had their own culture, their own personalities. They just happened to be like ships that people could live in. And as it turns out, Leviathans live for about 300 cycles in Farscape terminology, which are roughly equivalent to one Earth year. And so 300 years. Interesting fact, some of them are even allergic to pollen. If some gets on the ship, they can have an allergic reaction and it can impede navigation, just like in real life. So like other organisms, the bioships in this show could, get pregnant, give birth, and grow over time. So they might be a lot smaller when they're born, but they would grow to massive, massive sizes and bigger ships, basically. Ideally, they would bond with their pilots telepathically, although one point in the show is that some people can enslave Leviathans, although that's frowned upon by the nice people. But anyway, it's just a super interesting concept to imagine that you could live inside of an organism that you're kind of in almost like a symbiosis with, if you will, as long as it's not a slavery scenario, which is more of a parasite, if you think about it. But the fact that it's on this iceberg means that we probably need to ask ourselves the question, well, how did it evolve? Well, I don't know. To be honest with you, the idea of a bioship is pretty fantastical. Seems extremely unlikely that humans would be able to live in a creature that is capable of space travel. But, you never know. I will say the idea behind the bioship is maybe most interesting when you think of its relationship to the people that live on it. At best, it's symbiotic, and at worst, it's parasitic. It kind of reminds me of a remora on a shark. That's us on a bioship. Next up, we have the concept of anaerobic life. And you might be asking yourself, what is anaerobic life? I'm so happy you asked me that because I get to tell you. And that is, well, at least when it comes to Earth, there are two forms of life. Those that need oxygen at some point in their life, which is aerobic. We are aerobic organisms, and then the other type is those that don't need oxygen at any point in their life, and those are anaerobic organisms. We can further break down the idea of an anaerobic organism into three sections. The first are obligate anaerobes, which are microorganisms that are harmed by the presence of oxygen, so it actually hurts them or kills them. To break that down even further, most organisms, as you probably know, convert nutrients into energy through aerobic respiration, breathing oxygen essentially. Our cells use what's known as oxidative phosphorylation, which utilizes oxygen in the critical last step of that process to produce energy for us. And so oxygen is a big deal. Obligate anaerobes, on the other hand, may use sulfate, nitrate, iron, manganese, mercury, and even carbon monoxide instead of oxygen for their energy production. And this is called anaerobic respiration. The other option is they may use a process called fermentation, which bypasses the process of phosphorylation altogether. That's just another option. Could be fermentation, could be anaerobic respiration. The second type of anaerobe that we can talk about is what's known as aerotolerant, which means they tolerate oxygen's presence. It doesn't hurt them, but they exclusively use fermentation to produce energy, or ATP, if we want to get specific. The third type are what's known as facultative anaerobes, and these are organisms that make ATP energy by aerobic respiration if oxygen is present, but if oxygen is not present, they're capable of switching to fermentation for their energy production. That's pretty cool, and that's a very adaptable creature. And that group that we know so well now as the facultative anaerobes, it includes such all-stars as E. coli and the perennial favorite, Salmonella. That's right. Interestingly, up until the late 90s, scientists thought that all multicellular organisms needed oxygen at some point in their life to exist. But that all changed when scientists discovered a little creature known as Spinochloris cinzae. That's as good as it's going to get. A little cup-shaped fella that lives in the Mediterranean Sea. So could creatures on other planets do the same? Well, of course they could. I will say that the downside of anaerobic energy production is that it's not nearly as efficient as aerobic respiration, and neither is fermentation. And so as a result, if we were to find more multicellular organisms that used these processes versus aerobic respiration, we would probably find that they were very small. It would be hard for them to reach a large size because energy production would be so counterintuitive, if you will. But they may get around that if their food has a lot of phosphates, glucose, then they could break those down and access them a little bit easier than if they were relying on their own mechanisms to do it. Even still, we'd probably see them being pretty small So that's the idea of anaerobic life forms. And now we're moving on to plastic life forms. Now, I know we've all seen Toy Story, but that's not what this is talking about. The idea of a plastic life form was very difficult to research because I don't think most people have really considered that idea. But plastics are not unique to Earth, apparently, because there was a Cassini spacecraft that made a journey to Saturn's moon called Titan, and it located propylene in the atmosphere. Propylene, which is also called propene, not propane or propane accessories, but propene is a gas that smells kind of like gasoline. So it's got this pungent odor. So that's propylene. But the big deal with that is that it's also a building block for polypropylene, which is plastic that we would recognize on Earth. So if you look at a plastic jug or like a plastic bucket or something, you'll see the recycle symbol with the number 5 in there, and that signifies polypropylene. And so this discovery on Titan was the first discovery of plastic off of Earth, or the building block of plastic anyway. That's pretty cool. And to be honest with you, that's about all I could find on this. I guess maybe the other part of that question is, could life anywhere in the galaxy or the universe be based on plastic, just like humans are based on carbon, similar to the concepts of being based on silicon or boron or whatever we've talked about already? Maybe. I mean, I couldn't tell you because I couldn't research this too much because there's not a ton of information out there. But if anybody else has any more insight on this or would like to elaborate, feel free to leave me a comment. I would love to read it and delve into that a little bit more. But unfortunately, I'm just not smart enough on my own, so we're moving on. And we may have just saved the best for last, and this is All Your Yesterdays. This is the sequel to All Yesterdays. Remember that from a previous part of the Iceberg? Well, this was written by the same 3 people, C.M. Koseman, John Conway, and Darren Naish. It was published 5 years later than All Yesterdays in 2017, and it's a free ebook only, which I'll leave a link to in the description. You can check it out. And basically, there's artwork from people all over the world, and it was compiled into this kind of book format or ebook format. And so that's why it's called All Your Yesterdays. For a good example of what this might entail, you can see on the cover 2 young troodons, and here they're presented more like young birds waiting for their parents to return. They're not birds, at least, not the way we think of them, but they're also not quite like our traditional ideas of dinosaurs either. And so there's this kind of in between. And this is exactly what All Yesterdays was about. So we see different artists coming together and submitting for this. Or check out this pair of Ambulocetus, which are normally a creature that's depicted as like walking whales, just kind of swimming through the water or lurking in swamps. Maybe lumbering around on the shore. I remember a documentary called Walking with Prehistoric Beasts, another influential one in my childhood. But they're also usually depicted as naked, having no fur or very fine fur. But maybe they behave more like otters. That's what this picture kind of elicits, this feeling that they're kind of playful. Maybe they hang out in the open water just like otters do. But to me, one of the most interesting concepts from somebody who submitted an artwork has to be this, Spinosaurus. If you're anything like me, you're probably used to a depiction of Spinosaurus like this from Jurassic Park 3, which, by the way, a great movie no matter what anyone says, okay? But what if Spinosaurus's big spines supported a hump rather than a sail like we think of it? And more interestingly, what if they had a little trunk for breathing? They probably lived near the swampy, watery areas like baryonyx maybe, but maybe they had this little trunk they could stick up and breathe while they're under that water. Who's to say that they didn't? Nobody. For example, just as All Yesterdays presented, we wouldn't know if an elephant had a trunk if only we had their skeleton to look at. So maybe Spinosaurus had this little trunk. Who knows? There's just no way to know that. So anything speculative, and it's great. So again, if you want to see some excellent artwork, just like All Yesterdays, but by a whole bunch of people coming together for this project, you should definitely check out All Your Yesterdays. Again, link in the description. It's free. Check it out. And with that, Tier 4 is completed. We've got to get to Tier 5, the Astro Chicken. So for some context, let me ask you this. Have you ever heard of Freeman Dyson? Well, in case you haven't, he's quite a famous theoretical physicist, and he gave a lot of thought to the ways that humanity or alien life could harness energy, especially as their need for resources outgrew the resources of their home planet. Many of these ideas had to do with capturing the energy around a certain star and surrounding it with solar satellites, as they're called. He came up with quite a few ideas and ways that this could be accomplished, each with their own potential advantages and disadvantages. You've probably heard of some of them, and you don't even know it. For example, he came up with the Dyson sphere, the Dyson swarm, the Dyson shell, the Dyson bubble, and the Dyson vacuum. I promise that 4 out of 5 of those are true. Now, these are all extremely interesting, and they really deserve their own videos by somebody else. But these concepts are used a lot in science fiction for a lot of these advanced civilizations that need a lot of energy to fund their stuff. But for now, for this purpose, we have to focus on one of Dyson's lesser known thought experiments, the Astro Chicken. Now, before we get too far, it's not what you think, or what I thought when I first started reading this. I definitely thought it was going a different direction. It's a small 1 kilogram spacecraft. Also, it's a self-replicating automaton that could explore space more efficiently than a manned crew could, and this is due to its innovative mix of biological systems and technology. Now, if you watched the last video I did where we talked a bit about the bioship, this might seem a little more familiar, but it's not, okay? So before we can proceed, we need to define what an automaton is. An automaton, or automata for the plural, I know I'm pronouncing that correctly, is an abstract, self-propelled computing device that follows a predetermined sequence of operations automatically. Basically, the idea is that a small, self-replicating, self-sustaining ship or some kind of pod would be more efficient than a large one. So the Astro Chicken would be launched by a conventional spacecraft into space like an egg being laid into space. An Astro Chicken would then hatch and start growing a solar energy collector. The solar collector would then feed an ion drive engine that could power the craft. Once Astro Chicken entered a planet's vicinity, it would collect material from the moons and rings of the planet, taking in nutrients. So it's essentially self-sustaining in that it's kind of like eating the material that it's collecting. When necessary, it could land and take off using an auxiliary chemical rocket similar to something used by the bombardier beetle, a very biological creature. That's one way to put it. And then as it's going about this, it would periodically radio back to Earth and just let us know how it's doing. It's a probe essentially, but one that can self-sustain itself. So you might be asking, as always, what does this have to do with speculative evolution? And I have to tell you, well, the idea of a biotechnological ship could be thought of as the next advancement in the field of xenobiology, which is another thing we've talked about. Or it could be something completely different, but we're moving on. Next, we have just fascinating stuff. It's the Great Moon Hoax. So let me give you a little bit of background. In 1834, there was a very famous astronomer and a super smart guy named John Herschel. And in 1834, he traveled to a town called Cape Town, South Africa. His goal was to observe the heavens. And let me tell you, anytime this guy looked through a telescope, you knew he was going to find some stuff. Something monumental was about to happen for science when this guy decided to take it on. Now, he did find some stuff, but there's one thing in particular that caught the public's eye. A year later, on August 25th, 1835, the New York Sun, which was a brand new paper, published a 6-part series on Sir Herschel's findings, many of which were almost too amazing to be believed. First, I should mention that the Sun reported that he, in tandem with these amazing findings, had invented the world's largest telescope up to that point, which was 24 feet in diameter and 7 tons in weight. And of course, this was 6 times larger than what had ever been previously constructed, so that's a pretty amazing thing on its own. But not only that, he'd solved or corrected nearly every leading problem of mathematical astronomy. That's verbatim. This was quite the guy, according to the New York Sun. But that's definitely not all. When he pointed this giant telescope at the moon, he found life, vegetation, sand, bison-looking creatures, even unicorns. But do you think that's all? Of course not. No, there were humanoid creatures. And the descriptions given by the author of this series of articles, who had this inside information to what Sir Herschel had seen on the moon, described these humanoid bat-like creatures. They had wings that spread between their legs and their arms, which allowed them to flap and fly around in this utopia of a place called the moon. And I don't normally do this, but I'm just going to read a description given by the author of one of these series in the New York Sun because it's just too good. He describes what these creatures look like, obviously humanoid, bat-like in a way, and here's where it gets into the descriptions. They averaged 4 feet in height, were covered except on the face with short and glossy copper-colored hair, and had wings composed of a thin membrane, without hair, lying snugly upon their backs from the top of the shoulders to the calves of their legs. The face, which was of a yellowish color, was an improvement upon that of the large orangutan, so much so, but for their long wings they would look as well on a parade ground as some of the old Cockney militia. The hair of the head was a darker color than that of the body, closely curled but apparently not woolly, and arranged in 2 circles over the temples of the forehead. Their feet could only be seen as they were alternately lifted and walking, but from what we could see of them in so transient a view, they appeared thin and very protuberant at the heel. We could perceive that their wings possessed great expansion and were similar in structure to those of the bat, being a semi-transparent membrane expanded in curvilinear divisions by means of a straight radii, united at the back by dorsal integuments. But what astonished us most was the circumstance of this membrane being continued from the shoulders to the legs, united all the way down, though gradually decreasing in width. The wings seemed completely under the command of volition, for those of the creatures whom we saw bathing in the water spread them instantly to their full width, wave them as ducks do theirs to shake off the water, and then as instantly close them again in a compact form. So if that doesn't describe it in perfect detail, I don't know what does. It's a little hard to follow, sure, but here's some illustrations. There's people out there, who figured it out. Another quote says, "We scientifically denominated them as Vespertilio homo, or man-bat. They are doubtless innocent and happy creatures." What a nice thing to see on the moon, honestly. Later stories in this series told tales about the Temple of the Moon, which was constructed of sapphire and a roof of yellow resembling gold. So, a lot of people were asking at the time this was published, why can't we go see it? Where's the telescope that we can see this through? And they published an answer to that, saying, sadly, the telescope had been left facing east and the sun's rays concentrated through the lenses burned a hole 15 feet in circumference entirely through the reflecting chamber, putting the observatory out of commission for good. Still, even without the ability to see it, readers of the time were astounded and amazed. And so because of this, the New York paper, The Sun, was selling like crazy, and rival newspapers were rushing to keep up. Some even claimed to have access to the same stories. Of course, by now you're probably realizing that this was all some big hoax, which is true. But what's crazy about it is, even though they use the name of a real scientist, nobody really knows who actually wrote this series of articles describing the moon people. Eventually, The Sun came clean and revealed that it was all a bit of fantastic fiction. But amazingly, the readers were not upset about it. They took it in good humor, and The Sun continued to sell very well. It's pretty interesting, to be honest with you. It feels less like a hoax and more like a stimulation of the public's imagination, and that's what it worked for. In this era of history, science was really becoming more accessible to people, and they were becoming more interested. And so a story like this, instead of taking people off guard and making them angry that they'd been fooled, it made them more interested in science. So in that way, it really worked. I'm glad it happened, even though I wasn't there and I only just found out about it. So that is it. Next, we have atmospheric beasts. Now, according to the Cryptid Wiki, which I found online, atmospheric beasts sit at the heart of the confluence between ufology, cryptozoology, and astrobiology. So, needless to say, that gets me a little excited. But I will say that there's not a ton here. So temper your expectations on atmospheric beasts, but we're still going to talk about it a little bit. Basically, it's a speculative kind of animal that is rumored to inhabit the upper layers of the atmosphere, and it's been proposed as a reason for so many of these UFO sightings. So in other words, maybe what people are seeing are lighter than air creatures that actually live out their entire life cycles and exist up above the clouds, far away from where we can see them. Given different eyewitness accounts, it seems possible that they also shapeshift, because most of these atmospheric beasts appear to be like amoebas or blobs or jellyfish up in the air. Sometimes they're transparent, sometimes they appear to move about, not really maintaining any one shape necessarily, and sometimes they seem cloud-like. So there's just all these different ones, and nobody really knows exactly what these animals look like all the time, if that makes sense. So back when people were seeing things in the skies that we would call UFOs today, this was a very popular thought that maybe there were these atmospheric beasts, and that was the explanation. Of course, we began to think of them as technology-based, like spaceships and different stuff like that, up into the 50s, 40s, whatever it might be. But before that, atmospheric beasts seemed like a legitimately possible explanation. Now, air rods, or flying rods, as you may know them, is a type of cryptid that's very popular, and these could be considered a form of atmospheric beast, but we don't want to talk about that just yet because that's coming up later, okay? The idea of creatures living up in the atmosphere has even led to famous accounts of cryptids like the Crawfordsville monster, which was first sighted in Indiana in 1891. According to the Crawfordsville Journal at the time, this creature was sighted about 18 feet feet long and 8 feet wide and moved rapidly through the air by means of several pairs of side fins. It was pure white and had no definite shape or form, resembling somewhat a great white shroud fitted with propelling fins. There was no tail or head visible, but there was one great flaming eye, and a sort of wheezing plaintive sound was emitted from a mouth which was invisible. It flapped like a flag in the winds as it came on, and frequently gave a great squirm, as though suffering unutterable agony. How's that for a cryptid sighting? Apparently, this was later chalked up to a very large flock of killdeer, which is not as interesting an explanation, but who knows. There's also the idea of atmospheric jellyfish, which I briefly mentioned, though these sightings of the jellyfish, as it were, seem to be more illusions caused by the Earth's magnetic field, like the northern lights or something like that. Still, I will say that the idea of lighter-than-air organisms that exist beyond the clouds and only come down occasionally so that we might catch a glimpse of them is very interesting, to say the least. Next, we have non-water solvents. This will require some explanation, just as much of this iceberg does, because we need to describe what a solvent is. And on Earth, the main solvent is water. This means that it dissolves various chemicals into solution so that they can be transported more easily between cells, basically. So that's why our bodies need that sweet, sweet H2O. Water is in every living cell on Earth. Have you ever thought about that? It's kind of a big deal. But what if alien life existed on planets without water? Surely their biochemistry would require some kind of solvent, right? So this has been a question that has been the subject of some interest by scientists, and one of the most likely alternatives to water for a solvent is ammonia. Ammonia is mostly toxic to animal life on Earth, but it actually has a number of qualities that are very similar to water and may make it a pretty good option as a solvent for life on another planet. Ammonia dissolves numerous chemicals, much like water. It forms compounds without being either too stable or too reactive, and it is relatively common in the universe. But for this to work, the planet needs to be fairly ammonia rich. So, obviously there needs to be ammonia around to use, and it just so happens that the gas giants in our solar system are rich in ammonia, so who knows what might be out there. Now, water would be very uncommon on a planet like this, because chemically speaking, ammonia is a base, and so biochemistry based on ammonia would also likely be a base in nature, which would mean that water would likely function as an acid. So that means that basically water would need to be rare in order for this life to succeed. And then the other thing is that the atmosphere would likely not have much oxygen on it, because ammonia is made up of nitrogen and hydrogen, and so too much oxygen in the atmosphere would likely cause the hydrogen in ammonia to bond with the oxygen in the atmosphere and form water. So we need there to be only a little oxygen, enough for this ammonia-based life to exist. And so, the planet that I'm describing would be very inhospitable to human life. So the idea of us going there would likely require quite a bit of technological advancement or something. Now, ammonia might be maybe one of the most likely alternatives to water in terms of solvents, but there are other options that scientists have looked at, but we just don't have enough time to go into all of them here. One of them is hydrogen fluoride, another is hydrogen peroxide. These are definite options, but I'll leave some links in the description if you want to read more about this. I don't have time, okay? But this goes right back to our earlier discussion in the iceberg when we talked about silicon-based life, because that kind of a life form would be most likely to use ammonia as its solvent. Next on the list, we have something called the Brookings Report. And after doing some research, I found that what this is referring to is a little pamphlet or article or study, whatever you want to call it, called Proposed Studies on the Implications of Peaceful Space Activities for Human Affairs. So that's kind of a mouthful. Most people just call it the Brookings Report. And this was a 1960 report commissioned by NASA. And the idea was that it would look at the implications of discovering life and what that would mean for society, basically, and how human government or just the public at large might react to that. Basically, the idea was that we need to think about the idea that we might find life out there. How would that impact us? So this is, it's pretty interesting, that's for sure. And you know me, I don't find many things interesting in this world. There was quite a bit to the report. and not all of it was about extraterrestrial life, but the part that's most often cited is, and the part that is most likely relevant to this iceberg is as well. During certain parts, the authors contemplated the possibility that contact might be made with extraterrestrial intelligence, and they warned that this might not be such a good thing. For example, on page 103, it says, "It has been speculated that of all groups, scientists and engineers might be the most devastated by the discovery of relatively superior creatures, since these professions are most clearly associated with the mastery of nature rather than with the understanding and expression of man." So, I mean, that's one thing. The other thing they looked at, though, was the good side, and this was page 183. "The knowledge that life existed in other parts of the universe might lead to a greater unity of men on Earth, based on the oneness of man or on the age-old assumption that any stranger is threatening. Much would depend on what, if anything, was communicated between man and the other beings." So, to summarize, this report looked at the idea that we might find extraterrestrial life and the fact that a lot of people wouldn't take it well, especially in the scientific community, among certain groups of people on Earth, whereas otherwise, depending on what was communicated between us, if anything, and the aliens that we, discovered, maybe it would unite us, possibly in fear of what we might find out there. So that's the Brookings Report. To be honest with you, it is at the heart of some UFO conspiracies, which is not really in the scope of this iceberg, but there was a lot of people thinking that it was part of a larger study used to cover up the existence, or the reasons to cover up the existence, of extraterrestrial life from the public. If they weren't going to receive it well, maybe we shouldn't tell them about it. I'm not going to comment on that, but in relation to the speculative evolution iceberg, I don't know. I might need some help on this one. I mean, I guess it has to do with the idea that we might see alien life, but I don't necessarily see the speculative evolution or even the speculative biology part of it. So if anybody has some more information on that, let me know. That's about all I can find. Next on the list is the azotosome. So this one is pretty cool when it comes to the world of speculative biology, because it presents a model for how a cell may develop on a world without an oxygen-rich atmosphere and possibly without water as a solvent. So as we've already looked at some of those, this just ties right into it. It's pretty cool. So on Earth, our cells, in order to pass nutrients to each other and, eliminate waste and different stuff like that, they use a lipid bilayer membrane between them, and it's water permeable, so that's what allows it to happen, and it's the foundation of life on Earth. It's just this ability of the lipid bilayer. But, obviously this type of cell is not viable if we were to think of a biology based on something other than water, or in a planet that didn't have it. But unlike the idea of ammonia, which we discussed, the idea of the azotosome has to do with methane. And so this would be a methane-rich planet. And so in a study performed by a group of scientists, they were able to model a cell that was capable of similar functions to a cell that used water through its lipid bilayer. And so this led the scientists to propose a new type of membrane altogether, composed of small organic nitrogen compounds. And this is capable of forming and functioning in liquid methane at cryogenic temperatures. So basically, as long as the planet is really cold and has liquid methane on its surface or wherever these cells might be, then this different type of membrane would allow the cell to do the same things that the cells do on Earth, using methane instead of water. Now, how might this be useful? Well, as it turns out, Saturn's moon Titan appears to have seas of liquid methane and a nitrogen-based atmosphere. So the idea of modeling a cell that could survive and function in an atmosphere similar to Titan's, or Titan's itself, may mean that we could find life there if it adapted in certain ways. So the bottom line is that life on Earth functions one way, and we might find life on Titan, for example, or just another planet that functions in a different way, similar to Earth, but using completely different compounds, completely different solvents, and completely different atmospheres. And this just provides a model for what that might look like. Now, since then, there have been some studies that say maybe it's not quite as possible as those original scientists had claimed, but in any case, that makes for a very interesting concept. And so that is the idea of the azotosome. Next is the idea of the shadow biosphere. But let me ask you this before we go on. Have you ever thought of subscribing? Because that is something that I would appreciate. That's all I'm going to say. We're moving on. Now, at first, the idea of the shadow biosphere may sound like some kind of freaky, otherworldly concept, and that's because it is. So the idea of the shadow biosphere is that early Earth hosted multiple origins of life, some of which produce chemical variations on life as we know it. And so here's the story behind this whole idea. Stephen Benner, Alonzo Ricardo, and Matthew Kerrigan, which were or are, I don't know if they still work there, biochemists at the University of Florida, they argued if organisms based on RNA once existed, they might still be alive today. But here's the thing, they would be unnoticed because they do not contain ribosomes, which are usually used to detect living microorganisms. So the idea is that if this certain type of life evolved alongside the life we know, based on DNA, we wouldn't know they're there because we're not looking for them specifically. And they suggest that we might be able to find creatures, organisms, part of this shadow biosphere in environments that are low in sulfur. I'm not sure what that has to do with it, but that was their suggestion. And here it gets even more interesting because a woman named Carol Cleland, who is a philosopher of science at the University of Colorado Boulder, argues that desert varnish, which is really weird, it's this basically substance that appears on rocks in the desert, and Native Americans even made drawings and carvings in desert varnish, scratching it away because it's a darker color. It appears on rocks in the desert. Nobody knows what it is exactly. They don't know if it's biological or non-biological, and so that's crazy. Like, this stuff appears on rocks and nobody knows what it is exactly. And so Carol Cleland suggested that this might be a candidate for a shadow biosphere. Since we don't know what it is, we don't know what we're looking for, maybe we're just not finding it. So it's just crazy to me to imagine that there's this entire biosphere of life that's completely unknown to us, coexisting with us, but we don't know what to look for, so we just haven't seen it, but it's there. And maybe to take it a step further, what if we don't have the means to currently detect it? We just don't know. But I suppose that's not too far off from when we didn't know about germs, or that our bodies were made up of small cells. So imagine how that might have rocked the world for people back then. This could be something similar. So that is the shadow biosphere. Next, we have the idea that octopus are aliens. Now, that's how it's worded on the Iceberg. There's been a huge debate as for the pluralization of the word octopus. There's the Latin octopi, which most people love. There's the English form octopuses. And then there's the Greek octopodes, octopodes. I think I'll go with the Latin because I like the way it sounds. So anyway, have you ever stopped to think about how freaking smart octopi are? I watched a documentary a while ago called My Octopus Teacher, and let's just say I didn't think I'd be bringing this up twice in this Iceberg. I brought it up before, but that documentary was amazing. It made me really appreciate octopi, what they're capable of in terms of intelligence, emotion, and it was a bit of a tearjerker. I'll just say that. You should definitely watch it. But anyway, after looking at them and learning about them even before that, it's no wonder why some people look at this and say, hey, that's probably an alien. It's not that far-fetched if you just don't think about it too much. But some people have thought about it too much, as it turns out. Being in the mollusk family, scientists have been perplexed for years as to why they have this extreme intelligence. Why did this intelligence appear for this family in particular, and why was it so sudden and seemingly? The Cambrian explosion is what they refer to. The idea that octopi are aliens isn't necessarily new, but it was never really focused on too much in the scientific community until 2018, when over 30 scientists published a research paper. They suggested that the Cambrian explosion was the result of extraterrestrial intervention. So to put it in the words of the research paper, they want to know, was the cause of the Cambrian explosion terrestrial or cosmic? And the paper takes the position that it was indeed cosmic, and it's essentially a reimagining of the idea of panspermia, which we've also talked about. The idea of panspermia suggests that life on Earth and possibly other planets was seeded by microorganisms from maybe a comet or an asteroid that either fell off onto Earth or collided with Earth at some point, and that gave rise to the life we see today. So yeah, that's pretty much the conclusion, was that the Cambrian explosion, which led to the very quick evolution, according to these scientists, of the octopus and its extreme intelligence, it points to the idea of panspermia, that alien life seeded our planet, and that octopuses, doesn't sound right to me, are here because of that, and not because they followed along a pattern that the rest of life on Earth did. So to say that the study or the research paper has its detractors is an understatement. Most people do not agree, but it certainly is an interesting concept to think about. And of course, there is also the idea that octopi are actually aliens from outer space in their current form, and that we just don't understand them because they're otherworldly by default. I don't know. Who am I to say? I mean, I doubt that that's true, but we're moving on. Now, next we have the Spore 2005 GDC. So this one took a little bit of research because it's extremely specific. But as it turns out, Spore is a video game, which I knew. I played it when it first came out, and my computer could barely run it because it was a family computer, and that just wasn't its intended purpose. I'm sure we can all identify with that. But it came out quite some time ago, but it was unveiled in 2005 at the Game Developers Conference. Now, you may have played games like SimCity or The Sims, developed by, in large part, a man named Will Wright, who worked on Spore as well, and he knew his way around procedurally generated concepts, and that was the idea behind Spore. It was originally intended as a video game to be a universal simulator, and so the idea was that you'd guide an organism from single cell to water-based to land to societies to space travel and exploration, where you'd spend a majority of the game traveling around, visiting procedurally generated planets, and just, having a great time. You'd be guiding an organism from single cell all the way up to space travel. That was the whole idea. That was what was unveiled in a very long walkthrough by Will Wright himself, who showed all these aspects of the game's functioning and working, and everybody was pretty excited. But what actually ended up getting released, it was more like a few sequences that were pretty small and could be finished relatively quickly. It skipped over the whole water-based life altogether. You went from cell to land to tribes, and each section of the game felt pretty shallow, especially compared to what was unveiled at the Game Developers Conference in 2005. So people were a little bit disappointed. It was still a good game, but it turns out the publisher, namely EA, had some things to say about its complexity, and so they wanted to dumb it down. The original developer, Will Wright, ended up leaving over that, and so what we got wasn't really what he intended, and it's a real bummer because people wanted to see what that game was going to be. Now, of course, the speculative evolution part of this comes in because Spore is a game about evolution. It's a game about taking life from a single-celled organisms to an interstellar society that explores like Star Trek. So, it was a pretty cool idea, but sadly, the footage from the 2005 GDC is the only thing that remains of that original vision, and we probably won't see anything like it anytime soon. But, I mean, the game was pretty cool, even in the way it got released. So that's the idea of Spore and the original vision given. Now, we could talk more about Spore, but specifically for this iceberg, it's talking about the 2005 GDC, and that about covers it in detail. So we're going to move on. Next is Linkos. Now, this is a language that basically one guy invented, and this guy was named Hans Freudenthal, and it was first described in 1960 by this very smart man, and in a book called Linkos, Design of a Language for Cosmic Intercourse, Part 1. That's right, he released a book called Part 1. That is bold. The idea behind Linkos is that it's a language designed to be understandable by almost any possible intelligence out there. Ideally extraterrestrial. That was the purpose for the design of this language. And it was designed to be broadcast through interstellar communication. So radio frequencies that we beam into space would be composed of this language. But why Linkos? Why not English or something else? Well, it's very easy to understand, at least for an intelligent life. And so it presents a number of concepts from basic to a little bit more advanced. And so it's almost this self-contained language that you don't need to go out and study and learn all about the language before you can learn about the concepts. The concepts are inherent in the language that it uses. So, for example, the way it broadcasts out into space is first you'll have the dictionary, in quotes. It basically sets up some mathematical concepts like greater than, lesser than, equals, plus and minus, and it does all these concepts using pulses. The sequence eventually introduces larger concepts built on the preceding sequences like time, space, matter, and even descriptions of human beings that they'd find on Earth. And so again, the idea is that the language is simple enough for an intelligence to decipher using universal concepts not related to our life on Earth specifically. So it was a pretty cool idea, but for decades nobody used Linkos. It was just not used. But in 1999, some scientists in Ukraine encoded a message in Linkos and broadcast it using one of their radio transmitters. And this was known as the cosmic call. Most interestingly, at least to me, some scientists have even thought of using Linkos, the language, to communicate with whales and dolphins, because it's clear sort of, that they're intelligent enough for a language. Maybe they would be able to interpret Linkos, given that it doesn't rely on words per se, but concepts conveyed in a more simple way. As I did my research, I discovered that this idea of Linkos falls more into the realm of what's known as xenolinguistics, which is an amazing idea for a field. Basically, alien language. That sounds amazing. But I'm not sure how it fits into speculative evolution, as with some other things on this iceberg. I will say that the idea of Linkos kind of blurs the line between xenolinguistics and xenobiology. But, with anything we talk about alien life, there's always an element of speculation there. If they could interpret a language at all, that's some speculation. So maybe that's how it relates. I don't know. Now, finally on our list, we have one that I added because I couldn't resist: Dinotopia. Have you heard of it? Well, you're about to. My experience with Dinotopia only exists because of the miniseries, which aired on ABC way back in 2002, the year the first Spider-Man came out. What a formative year that was for my childhood. And it was a wild ride, let me tell you that. It was a 3-part, 4-hour movie, basically. Again, it aired on ABC, and it was a joint production between Disney and Hallmark. Two very family-friendly production companies, and they did a pretty good job, I must say. So I didn't read them ever as a kid, but the series is based on a couple of books, also called Dinotopia, which were published in 1992 and 1995. I had to look at my notes respectively. So that's enough background on Dinotopia and when it aired and stuff. What is it exactly? Let's find out. The premise is this: somewhere out in the ocean, there's an unmapped island that has people living on it and dinosaurs coexisting, just having a great time. And in the series, two brothers and their father crash land their plane and wash ashore on this utopia of an island. But it's not just dinosaurs just like hanging out like the Flintstones or something like that. A lot of them have actually developed the ability to speak. They have human intelligence. They even wear clothes. Some of them are not so advanced. A lot of the predators still have retained their animal qualities, if you will, and so they're somewhat dangerous. But most of them are pretty nice. They have their own society where they're completely, basically like humans in terms of society. And there's one in particular that appears in the series who wasn't in the books. He's just a friendly fella, a Troodon, I believe, named Zippo. And, that's about it. We have these dinosaurs that exist alongside humans, human-like intelligence, but what is pretty impressive to me is for the time, especially in 2002, and for a TV series, very advanced CGI. It still holds up pretty well. I don't know, it's not HD or anything, but it's still pretty amazing. And, there's a whole lot to the story. It's mostly about the story, but I can't talk about it all in detail here. But I just wanted to bring it up because I love it so much, and I think it's a great example that belongs on this iceberg. After all, how did, dinosaurs like Zippo develop that ability to speak? Vocal cords, lips, for example, that can form words. There's a lot going into that isn't really covered, but that's okay. The books I discovered later, they're also worth checking out. The artwork is amazing. It won awards and different stuff like that. So, Dinotopia, what a work. I love it. Anyways, let's start with Tier 6, and that is the labeled release experiment. So prior to 1976, nobody had visited Mars, not a probe, not a manned spacecraft, which is still the case. I don't know why I brought that up, but in any case, in 1976, we touched down with 2 Viking landers, and they were the first of their kind, especially to land on Mars. And what they did was kind of what you'd expect for any lander to do. They took high-resolution images of the planet, they collected soil samples, and just generally explored. They had a great time. But one of the big things about it is that it performed experiments on the soil just to see what it was all about, what's it made of, and all this stuff. And one of them was called the Labeled Release Experiment, or LR experiment, and it showed something very interesting that nobody expected. Using a very sophisticated technique, it analyzed the soil and found that there were signs of metabolism happening there, and we'll get into what that means here in just a moment. But interestingly, other experiments that it performed found that there was no organic life found there, no microbes or anything like that. So they found signs of metabolism, but no signs of life. So where are they getting these results from? Well, in the 40 or so years since that experiment, scientists have been trying to figure out that exact thing. But before we can dive into exactly what that means or what they think, we need to talk about what the experiment entailed exactly. So here's how it worked. There were 2 landers, Viking 1 and Viking Viking 2, appropriately named, and they scooped up soil, and I'm just kind of reading because there's a lot to it, all right? They added a drop of dilute nutrient solution laced with radioactive carbon-14, and then monitored the air above the soil for signs of metabolic byproducts like carbon dioxide or methane. What was interesting about this was that on Earth, the scientists that designed the experiment had tested it in Earth conditions extensively, and they found that the experiment behaved exactly the way they would expect in every situation they tried, even simulating Martian atmosphere and stuff like that. As with any experiment, you need to have a control to make sure you're not just making stuff up. So the control for this experiment was that they would superheat the soil to kill any possible remnants of biological life and then see if it tested negative. So if it was positive and then they superheated it and it was negative, that's their control. If it was positive and still positive, or negative and then positive, I don't know, whatever, then it doesn't make any sense. But in this case, the two landers, Viking 1 and Viking 2, were each 4,000 miles apart on Mars, and they both reached the same conclusion in their results from that experiment. Not only that, but once they superheated the soil, they both tested the same soil, and it came negative for any signs of metabolism. So it seems very likely that there was something there, and it's just a matter of trying to figure out what it is. So the scientists on Earth were very perplexed by this, and they began to search for answers, as we all do. So there was a paper published by one of the original experimenters on that project, and this paper was published in Astrobiology in 1997 by Gilbert Levin. That's the guy's name, if you hadn't noticed. And since he did work on that original mission, he was very well versed in what it entailed. He also worked with a person named Dr. Patricia A. Stratt, just so you know. So these two original experimenters on this mission, by the way, spoiler alert, they both believe that these were actual signs of microbial life on Mars in some capacity. But they went through and first presented a few alternate hypotheses just to rule them out. And one of the arguments that a lot of scientists had brought up, well, hey, maybe what the landers detected in the soil was formate, which is a component of formic acid found naturally on Earth. A 2003 LR-type experiment found that formate in a soil sample from the Atacama Desert in South America produced a positive result, even though the soil contained virtually no microorganisms. So in this case, we're looking at a similar experiment on Earth, and it basically produced a false positive. And so there's some precedent for that, and it's due to formate. But here's the thing, that experiment did not include a sterilization control, which is that superheating of the soil in order to rule that out. And so it's also likely that the formate concentration in the desert in South America is much higher than that on Mars. So it's very possible that this experiment is not exactly analogous to the one performed on Mars. Another example briefly mentioned in the paper and followed up quite a few years later is the idea that maybe it's perchlorate or one of its breakdown products. In 2009, in fact, the Phoenix mission to Mars detected perchlorates in the Martian soil. But the conclusion is this: although perchlorates could yield a positive result because they produce gas when interacting with some amino acid, they don't break down at the temperatures that the sterilization control reached. And so what that means is that even after the control, they would continue to produce positive results. So it's unlikely that, given the control method of this experiment, that either one of those would be a good option. So they go through a couple of different ones, but I'll leave a link in the description about where you can read about that if you're so curious. And who wouldn't be? No non-biological agent. So at this point, the authors of that paper conclude that there are no non-biological agents that could account for what was detected by the Vikings 1 and 2 landers on Mars. Kind of relates to the shadow biosphere, which we talked about in one of the previous levels of this iceberg. But we have this life that we can't even detect. Maybe there's life that we don't have the technology to see, just like the Viking landers didn't. So who knows, But it does seem at this point that thanks to the labeled release experiments, we have discovered some byproducts of organic life. Who knows what we might find in subsequent visits to the red planet. Next on the list, we have the idea that the rangiomorph is a designed life form. Now, what is a rangiomorph, you might be asking yourself? Well, let me tell you all about it. Basically, this was a very successful type of life form that blanketed the ocean floor a very long time ago. And they look kind of like ferns. There were many different types, but they all shared something in common. They had these fractal patterns. Now, in case you didn't know, a fractal is a subset of Euclidean space with a fractal dimension that strictly exceeds its topological dimension. And that goes without saying, it's very obvious. But as it turns out, these already complex organisms may have been more complex than scientists originally thought. Now, when you're looking at them, you may think that they just look like regular old plants or something like that. And I'd forgive you for thinking that, but not for for long because scientists had learned that they formed dense colonies on the floor, and they seemed to have a method of communicating with each other, or at least that's what we think, because it was recently discovered that they had these long filaments that drifted in the water and connected them to other individuals. The question is, what are those used for? Well, we don't really know. Scientists speculate that it could have been used for reproduction or possibly even rudimentary communication. Wouldn't that be wild? The Rangiomorphs were extremely successful, and they were a big deal for quite a long time. It's kind of interesting because most scientists would tell you that the proliferation of life began at the Cambrian explosion, but scientists are also finding, and according to the fossil record, that these organisms were already very diverse even well before that. And so there's a lot going on here. I'm describing a creature, basically an animal, that lived on the ocean floor, very successful, had extremely complicated fractal patterns branching out and basically symmetrical on all sides, that they had these strange tendrils that seemed to let them communicate, and then also they were doing a really good job well before life on Earth exploded, if you will. And to kind of really drive this point home about how unique these animals were, let's hear a quote from Francis Dunn, who is kind of an expert on these subjects. Rangiomorphs have been something of a paleontological conundrum for a long time, in large part because their body plans are so odd, she says. It's difficult to rationalize them with things that are alive today. This branching architecture really is totally unique for most living things. So I am kind of leading up to something, I don't know, maybe you could tell, but if these Rangiomorphs were so advanced well before the proliferation of life, if you will, is it possible that they are the result of panspermia? I bet you didn't think I would bring that up again, but here we are, because there's kind of this theory floating around that maybe these things were seeded on Earth, maybe like an asteroid or a comet. Generally, the idea of panspermia, could this be an example of that? Well, we've already discussed that octopi seem to come from that, at least according to some people. Now, it's kind of also interesting because it turns out these Rangiomorphs, which scientists also thought went extinct around the same time as the Cambrian, apparently persisted quite a lot longer than they originally thought. So they seemed to do well, but they were soon replaced, relatively speaking, by other forms of life. So is it possible that these were a kind of experiment by an alien life? Or maybe they just kind of came up on their own after falling off a meteor after passing Earth. Who knows, It just seems very strange, given that these things are in the fossil record and are so unlike anything in its contemporary time or even into the future, even today. So that's the idea. And that is why a lot of people think that the Rangiomorph is a designed life form. Moving right along. Next, we have the idea of flying rods. Now, earlier in the Iceberg, when we discussed atmospheric beast, I alluded to the fact that we would be back to talk about flying rods. And here we are, They occupy their own space on this iceberg because they're so important. Now, a lot of people would consider these cryptids part of the Cryptozoologicon, if you will. But their place on this iceberg, there's a reason for it, and we're going to discuss it. Now, of course, they're described here as flying rods, but a lot of people also call them air rods or skyfish, which is a great name, and I think I'll call them that from now on. But the interesting thing about these skyfish is that they've never been seen with the naked eye, so this adds another layer of mystery to them. They are only caught on camera. So what does that mean exactly? Well, let's talk about it. Now, I know what you're thinking. If you see pictures of these skyfish, the question is, aren't those probably just bugs flying really fast? Wow, what a dumb question. If these skyfish could be explained by rational phenomenon, don't you think that they wouldn't have covered it in an episode of Monster Quest? And would that episode then have interviewed an air rods expert? No, of course. So there is a rational idea behind it, but it's not a flying bug. That's ridiculous. Now, one of the more popular theories is that these skyfish are living creatures, perhaps even interdimensional beings. So put that in your pipe and smoke it, you know what I'm talking about? But it is interesting that these things never show up to the naked eye and only on camera. So why is that? Well, the skeptics out there will say that it's basically an artifact of interlacing, which is a technology that cameras use. And let me just read to you what interlacing is, because I don't fully understand it. But in interlaced video footage, multiple still frames are placed in a single frame of the replayed video, increasing the perceived frame rate without consuming extra bandwidth. Once the video is interlaced, insects that would appear to be moving as normal are displayed as air rods. In still footage, rods appear in elongated shutter exposure speeds when moving insects are captured on film multiple times along their path of flight, appearing to form air rods. But come on, man, that's a really boring answer. I want to believe. Now, in relation to speculative biology, we have to ask ourselves, how could a being fly through the air with the greatest of ease at such high speeds, especially? Well, a lot of that goes back to our conversation on atmospheric beasts. We have to think of these things as, lighter than air or possessing some form of propulsion, although that seems unlikely given their morphology. But we could think of them as interdimensional because they do sometimes appear to move really fast and then kind of go out of existence briefly and then come back very far ahead of where we last saw them. So, it's possible, maybe they're living creatures just flying around up there, coming in occasionally from another dimension, and maybe they're composed of some type of matter that we don't necessarily understand. For example, take a regular bird, all right? Birds can see ultraviolet light. And so as a result, when they look at another bird, they see things that we don't. They see feathers reflecting light in a way that we don't, because we don't have the ability to perceive ultraviolet light, whereas they do. Maybe it's a situation like that where they're made of something that our human eyes can't detect, but cameras can. Maybe they're not even living beasts at all, That is how it relates to this iceberg, but maybe they're UFOs, which implies aliens. At the end of the day, all the speculation, whether it's a bug, an interdimensional being, a spacecraft of some kind, it's just interesting to think, much like the fact that there could be microbes among us that we never see, or things so small that we never detect them. Maybe there's something up in the sky that we never see, made of different materials than we can comprehend. Maybe there's something floating around that we can comprehend, but we just can't see it because it's invisible. These are the options. Maybe Wonder Woman's up there in her jet. These are questions that keep us up at night, but we can't spend too long on it because we got to move on. Next, we have the concept of the black cloud. Now, this one kind of relates into the next one. This is a bit of a spoiler, but we're going to talk also about plasma/dust-based life, and they go hand in hand, so I'm bringing it up now. But the black cloud is a specific instance of how some people, mainly one guy, think that a dust-based organism could exist, or at least what would happen if it did. So let's just get to it here. It's a 1957 novel by the same name, The Black Cloud, by a man named Sir Fred Hoyle, he's kind of a big deal. So before we get to the book, we have to talk about him for a second. He was an English astronomer and quite a brilliant man. He formulated the idea of something called stellar nucleosynthesis, which, as everyone knows, is the creation of chemical elements by nuclear fusion within stars. And actually, that's one that we may have learned in science class, but it's the idea that chemical elements are fused and created within stars. So that's something we kind of take for granted as a theory now, but he's the one who came up with it. But he was equally well known for his less conventional beliefs. And this is where it gets interesting. For example, even though he literally coined the term Big Bang, which, yeah, that's the one, he rejected it as a valid theory. Instead, and buckle up for this one, he was more into the idea of panspermia. That's what he saw as the most likely source of the origin of life on Earth. What an interesting guy. Anyway, in 1957, he wrote a novel called The Black Cloud, and here's the gist. In 1964, some scientists look up at the sky and see a very distant but very large cloud of gas and dust just hurtling for our solar system. So in the book, the main concern for this group of scientists is that if that cloud were to come between us and the sun, things on Earth would not go so well. As we know, photosynthesis would cease and big climate changes would occur very rapidly, and it would just be a generally bad time. So they were concerned about that. And so a majority of the book is showcasing these discussions between these very smart scientists. And, let's just say that eventually the cloud does enter our solar system, decelerates, and settles around the sun. And that causes us a whole lot of problems, as you might have guessed. But it's the fact that it seemed to slow down and then intentionally went to the sun almost, that the scientists thought, hey, maybe this thing is intelligent. And so they attempt and manage to communicate with it. The cloud is revealed to be an alien gaseous superorganism many times more intelligent than humans, which is surprised to find intelligent life forms on a solid planet. Once it discovers this, it reconfigures itself to allow rays from the sun to come to Earth again, and we're saved. So we're really lucky that this thing is nice. So when the astronomers ask the cloud how its life form originated, it replies that they have always existed. And one of the characters in the book suggests that this is incompatible with the Big Bang Theory, which is a little bit of the author kind of projecting his own views into the realm of the novel, which is, that's allowed. So eventually in the story, the cloud moves on and humanity is good to go. So what's kind of unique about this book is that at the time, the idea of a gaseous superorganism that is intelligent was very, very unique in the realm of science fiction. And to be honest with you, it still is. The fact that this life form states that it has always existed leaves little room for speculation as to its origins, though, so we can't really speculate on that, but it is fun to think about its biology. For example, is it necessary for the organism to have a nervous system like we might imagine? I mean, there's just so many things that we couldn't understand about how this works. Or could we? That leads us right into the next topic of plasma/dust-based life. Now it was new to me, so it was really interesting to talk about and research, I must say. And so we have to discuss plasma and what that is. And as you may know, it's basically a superheated gas. Unlike gas, though, plasma is capable of conducting electricity, which is just wild. One form of plasma you may be familiar with is lightning. Wow. So with that previous idea of the black cloud in mind, let's talk a little bit about how a cloud-like organism may be possible, starting with the plasma. So way back when, a scientist named David Bohm discovered that when electrons are deposited in plasma, they start behaving very similarly to a live organism. For example, the plasma will shift and it will open and enclose around impurities, much like a living cell might do. But that, the fact that it kind of appears to behave overall as a living organism, based on these observations, it isn't truly life, but there is a plasma cosmologist named Donald Scott who says that a plasma double layer can act much like a membrane that divides a biological cell. So they had it almost as if this plasma, and electrons within it, of course, have this ability to mimic life. Or maybe they're not mimicking at all. And this is my own speculation, but if plasma conducts electricity, and if electrons can seem to form living structures, is it so far-fetched to think that it could somehow organize itself into something more complex? Well, before we can get into that too much, we have to talk about dust. And what does that mean exactly? Well, dust and plasma, they go hand in hand, just like that. In fact, there was a guy named Gregor Morfill of the Max Planck Institute for Extraterrestrial Physics, and that's in Germany, and he built a computer simulation to model what happens to dust immersed in plasma. So these guys ran a simulation and found that electrically charged dust can organize itself into DNA-like double helixes. So overall, essentially, these dust particles are acting like a nucleus. They attract electrons and they form a negative charge. Then positive ions are attracted, which forms a kind of shell around the particle, much like a cell might do around the nucleus. And then, as I mentioned, the simulation indicated that these will form double helixes, much like DNA. But even more amazing than that, these dust spirals can actually store and pass along information, much like DNA does with genetic code. So now we come to the real question and the purpose for this iceberg. Do organisms based on dust and plasma already exist? Who's to say? One thing, though, is that gravity would pose a real problem because as it passes near a planet or something like that, it could get ripped apart. But one way it could get around that is by living in planetary rings, much like those on Saturn. And that's exactly what one scientist thinks. I'll leave a link to these things in the description, so don't worry. We may have to go find out whether something like this could exist in one of these rings, so we're going to have to go to Saturn and just see. And while we're there, we could check out Titan and see if there's anything there. We've already discussed that. But man, what an interesting thought that we can observe and model these forms of life that are completely foreign to our own sensibilities in terms of cells and biological systems. But man, wouldn't it be crazy to find out that something like that exists? And if it was intelligent, could we communicate with it? Obviously they did in the novel, but who's to say that we would even be close to understanding how it thinks or how it might communicate? Man, there's too much to get into, but it's so interesting. So we're going to move on to the Columbia disaster microorganisms. This one's kind of short. So as you may recall, for those of us who are old enough, in 2003, the Space Shuttle Columbia launched its final mission. It went into space, and as it was coming back with, I believe, 7 astronauts on board, unfortunately broke up on re-entry and everyone on board died. It was extremely sad, and I remember all the news coverage. Man, It was tragic. And as any good scientist would do, they did manage to find some good to come out of it. And that is, well, let's just say on board there was an experiment going on, much like any scientist would do. And part of that experiment was to have a strain of bacteria called Microbispora, and it was in this container on board the Columbia shuttle. When it came back into reentry, broke apart, and a lot of it burned up, they actually found that container of those microorganisms in a convenience store parking lot. And the scientist who was the conductor of the experiment kind of located it and basically assumed that everything would be dead. But guess what? It wasn't. These microorganisms survived the heat of reentry into Earth's atmosphere. So that gave scientists a lot to think about. I think previously, the fact that this was such a big deal implies that previously they did not think that that would be possible. But they discovered that if microorganisms can survive the heat of reentry, could that mean that they could have landed on Earth in the distant past and seeded this world, maybe hitching a ride on a meteorite or whatever they're called when they hit Earth, an asteroid, I guess. Well, that's right. We're coming right back to this idea of panspermia. So we've already talked about all the ways that people think life on Earth was seeded, but we haven't really discussed the nuts and bolts of how that might occur. And this just adds one little piece to that puzzle, where we discover that there are organisms out there that can survive the intense heat and the vacuum of space, by the way. So if you thought that panspermia was far-fetched, could this change your mind? I don't know. That is up to you. But we're moving on. Now we come to a little thing called Perilandra. Now that's the only name given on this iceberg. But by the way, I just have to say that I reached out to the author of this iceberg, Pesterjust, who hopefully is continuing to watch these videos. I deeply appreciate their help because they were able to give me a lot of information on some of these lesser known topics and why they were included on this iceberg. So they really helped me flesh out some of these. Thank you very much, by the way. And of course, I will leave a link in the description to their Instagram and basically their stuff. Anyway, moving right along. Have you ever heard of the Chronicles of Narnia? Well, you probably have. It was a book series that was written, I believe, in the 50s or late 40s that I really, really loved as a kid. I used to listen to them, BBC radio dramatization, and that was a lot of fun. But it was written by a guy named C.S. Lewis. Clive Staples Lewis, if you will. And that's, I guess you could say, one of the things he's most famous for is the Chronicles of Narnia, Lion, the Witch, and the Wardrobe, all that good stuff. But he wrote another series prior to that that gets considerably less attention, but it's very, very good, and it's called the Space Trilogy. And so he wrote these in the late 1930s/early 1940s while the world was at war. And like the Chronicles of Narnia, if you didn't know, both of these are an allegory for kind of a Christian perspective. So they take a lot of biblical concepts and Christian concepts and kind of distill them into a narrative of fiction, but it's pretty transparent, so I don't think that comes as a surprise to anyone, and the Space Trilogy is no exception. So in the series, the protagonist visits Mars and Venus before going back to Earth in the third book, and we don't need to get into the story here because it's not really relevant, but the books are very good. I would highly recommend that you read them if you're at all interested. But anyway, in the second book, which is the title of this spot on the iceberg, Perilandra, the protagonist visits Venus, which the planet is called Perilandra in the book, so that's where that comes from. Now, the reason that this is on the iceberg is because of the way that C.S. Lewis's writing reflects the scientific thought at the time that the books were written. So in the novel, Venus is described as an ocean world with many floating islands made of reeds, basically plants floating along, and it's a completely, every island is completely non-solid. It just rocks with the waves, except there is one piece of land, and that's the only one on the entire planet, and that figures into the narrative. But other than that, it's all an ocean world. Now, here's where it gets kind of interesting from the scientific perspective. Prior to the 1960s, I believe, all of our knowledge of Venus was based on, obviously, Earth-based observations, so telescopes. And so at that time, scientists thought that it was an ocean planet. That's just what they thought. So the Space Trilogy was a product of its time in that regard. And it wasn't until the late 1960s when Soviet probes landed on Venus that we discovered it to be much less hospitable than we thought. It's basically a desert planet with sulfur rain, acid rain, that evaporates before it even hits the ground because it's so hot. And so it's not exactly an ocean paradise as the space trilogy might have us believe, but it's interesting to think about nonetheless. So yeah, that's a bit different, but NASA says that Venus could have been a watery planet at some point, so maybe there was some truth to it. That's kind of interesting. By the way, as we talk about speculative biology, there's a fair amount of that going on in these books. Mostly they're just kind of like plays on Earth life, but with slight differences. Like there's bird-like animals, there's mermaid-like animals, or merman, if you will. But none of the creatures on this planet are sapient. And there's also this dragon-looking thing, which is about the size of a dog. And here's kind of an artist depiction. Kind of creepy, not gonna lie, at least the way it's drawn here, but in the book he's a pretty nice guy, so can't judge him too harshly. I think why this is on the iceberg is that it's just interesting to get a glimpse into what people thought of the other planets in our solar system before the advent of unmanned space travel. So that's what this book does for us. And again, if you're interested at all in reading any of C.S. Lewis's less famous work, other than the magnum opus of the Chronicles of Narnia, I'd also recommend reading his essay. It's called Religion and Rocketry. Disclaimer, if in case it wasn't clear, this is from a distinctly Christian-based perspective, but if that appeals to you in any way, he's a very good writer. What a smart guy, and it's just it's an interesting read, so check that out. As always, link in the description. Next on the iceberg, we have Gauss's Pythagorean right triangle proposal. Ever since humanity has dreamed of alien life, we've dreamed of ways to contact them. But it wasn't until very recently with things like radio communication, satellites, all this stuff, actually people going into space, where we have these ways of broadcasting communications over vast distances, including deep into deep space. So way back in the 19th century, though, this was not an option. So what did we do? We still wanted to give the impression to alien life that, hey, we want to communicate, we want to talk to you, but we don't have a way to do that necessarily. So in the 19th century, there was a guy named Carl Friedrich Gauss who came up with a great way to basically let any alien life out there know, hey, we here on Earth, we're smart, okay? And we want to talk. So in 1820, he proposed that we could draw a huge right triangle into the Siberian tundra using trees to form kind of the outline of the triangle, and as well, 3 bordering squares that would indicate, hey, we understand math, we're smart, and just believe us, okay? This is proof. This would represent the Pythagorean theorem large enough to be seen even from Mars, okay? That's pretty big. And so a passing ET would say, hey, they know about math. Let's go down and talk to them. Well, that never ended up happening, but to Carl, I say that was a pretty good idea, and I'm sorry we didn't do it, although, it wasn't that much longer until we figured out how to broadcast radio signals, so it was fairly quickly outdated, at least in the grand scheme of things, but pretty smart idea. A lot of people thought at the time, this is smart, but it was just too big of an undertaking to perform. So that is Gauss's Pythagorean right triangle proposal. So we've come to the end of this tier of the iceberg, at least what was originally on it, but I decided to add something. It's called Epona. Isn't that the name of Link's horse in Ocarina of Time? Well, yeah, it is, but this has nothing to do with that, so I'm sorry to disappoint you. In reality, you could call it the Epona Project, which is, well, it began life as a world-building exercise, which we've already discussed world-building in depth, and they go really hand-in-hand with speculative biology. And so what would eventually turn into the Epona Project began at the Cultures of Imagination Conference, which was way back in 1993. A group of very smart individuals who all had this shared passion for kind of astrobiology and all things science came together and, led by Martin J. Fogg, designed a hypothetical solar system around the known characteristics of the star 82 Eridani. So that's the definition of what it is. And basically, they really all contributed to this speculative project. And it's more than just a few animals here and there, or animals, if you will. It's an entire solar system based on a star that actually exists. And the project is very, very detailed. It's pretty nerdy, I'm not going to lie, but that's exactly what I love. So, 82 Eridani is a real star. It's about 20 light years away. It's found in the constellation Eridanus. So, scientists know a decent amount about that star, And so the Epona project takes into account, all the scientific readings and stuff and how that might influence nearby planets. And scientists also believe that actually there are multiple planets surrounding that star, but they don't know much about them individually. But the people that are working on the Epona project, they kind of are formulating an idea just based on the characteristics of that star. So let's talk about Epona a bit. It has large polar ice caps, much bigger than those on Earth. And by the way, Epona is the planet that we're discussing. The atmosphere is similar to Earth's, but with generally higher wind speeds. There is no moon on Epona, so I guess there's no tides, although I'm sure that's covered. I didn't actually see that. And the seasons are much more extreme than those on Earth. There are hotter summers and much colder winters, so that kind of gives you an idea of what Epona is. And it's basically a fantastic exercise in world building, which, man, it's just fun to read about. There are multiple types of flora and fauna that you'll find on the planet, and I must say, navigating the website, if that's something that interests you, it's a nightmare. All right. I don't know if how much it's been updated since 1993, but it can't have been that much. Or if so, not in the way that would make it easy to navigate. So let's take a look at a few examples, although again, kind of hard to find. For one, here's the segmented dragonfly. Now, it's not just one organism though, it's basically 5 lesser creatures, and these individual creatures are no longer true individuals. They make up segments of the whole, and it's kind of like the insect version of the human centipede. That's exactly how it works. It shares a digestive system by having their mouth parts of one organism attached to the tail end, if you will, of the organism in front of it. But that's how it works for them, and they really like it. Although I guess the insect version of a human centipede is just a regular centipede, but you get the idea. Then there's something called the spring croc. And this thing is weird. I don't really know what else to say about it. Now, we can't mention the world of Epona without mentioning that it was mentioned. That's a lot of the word mentioned for one sentence, but in the documentary Natural History of an Alien, which we've already discussed on this Iceberg, they talk quite a bit about Epona because it was kind of a big deal at the time, I guess. And so here's a few clips, you can kind of see what they had going for it. A lot of the images that you'll find, even on the website today, are computer generated by computers way back from the 90s, and this is a very good idea of what you can expect. But clearly they've built out a whole world with unique forests and unique life forms. It's quite, I would say, the original collaborative speculative biology project. And so you want to do a little history, go check that one out. People are still contributing to this project. And with that, we've reached the end of Tier 6. And so let's move on to Tier number 7. All right, and so now we are on to Tier 7. And by the way, I did not stop recording on one day and come back another day. I just changed my clothes in between. So anyway, from here on out, from Tier 7 and Tier 8, things get a little less grounded in reality, or at least speculated reality, and into some, I would say, stranger territory. So to be honest, the lower levels of this iceberg get a little bit memey, a little bit tongue-in-cheek, if you will, but that's all right. It's all part of the joy. It's still fun to take a look at them. So as we proceed, though, I'm going to leave it up to you to decide which ones are serious and which ones are, not so much. So let's begin with Australian Mimi hominid subspecies. So that's how it's laid out on this iceberg. That's the title. Now we have to give you a little bit of background on what the Mimi is. As with everything else, I hope I'm pronouncing that correctly, but guess we'll find out. The Mimis are spirits of legend in Northern Australian Aboriginal folklore. The legend goes a little something like this. Before the first Aboriginal people came to Northern Australia, the Mimis lived there already, and they were in human form. That's important. They were making rock paintings and generally just living their life, having a great time. So when the Aboriginal people first discovered them, the Mimis kindly showed them how to paint, cook, hunt. They just shared a lot of knowledge with them. That's how the legend goes. Eventually, the Mimis transformed in a way, but they were no longer in these humanoid forms, or at least not so much. They had these very long and thin bodies. So long and thin, in fact, that if a strong wind came along, it could potentially snap them in half. Kind of reminds me of the Striders from All Tomorrows, but anyway. Because of that, they were so fragile, they couldn't be caught out in the open as often as you would think. They stuck to rock crevices and just lived in there, rarely coming out, and sometimes it would be a little mischievous and cause some trouble for the Aboriginal people, but otherwise they were mostly harmless and relatively nice even. So that's the myth of the Australian Mimis, which you'll find in a lot of Aboriginal artwork and different stuff stuff like that. But the question is this: were they based on fact? Well, to kind of talk about that, let's back up a little bit and talk about how humanoid creatures allegedly arrived in Australia. So back in the 1930s, there was a group of anthropologists who claimed that there were at least 3 different separate migrations of people to Australia. Each subsequent race that migrated wiped out the preceding one, and one of these was said to be a race of pygmy people that were eventually wiped out when the Aboriginal people migrated there. This would have been thousands of years ago, according to these anthropologists. The question is, could the source of the Mimi myth be linked to one of these pygmy peoples? Well, no. Because as it turns out, this theory of multiple migrations and then the Aboriginal people only being the latest in a succession of races to wipe out the previous one is a myth that's been debunked since then. There's no scientific evidence for it. So I bring that up because a lot of people have thought it for such a long time, or at least it's been a debated topic in the scientific community. But at best, it's based on zero evidence and so shouldn't really be considered. And at worst, it's been used as justification for taking land away from the Aboriginal people because, they weren't the original owners of it either. The only original owners are already dead. So they have no claim to it. So it's kind of a sad story, to be honest with you, used as justification for that. So while the Mimi legend may not line up exactly with scientific evidence, the question remains, is it possible that the Aboriginal people interacted with some other form of human subspecies, shared their knowledge with them, and then eventually kind of incorporated them into legend? Maybe it was even an unknown species of a human relative, who knows? But it brings up an interesting idea. Who knows how many human civilizations, however primitive they may seem to us, have come and gone and maybe even developed some advanced forms of technology, but left no record of their existence, other than what we now dismiss as a myth. The legend of these Mimis sharing, in a sense, culture and a sort of technology, it kind of makes you wonder, has this happened? And if so, how many times in human civilization? So that's about it for Australian Mimi hominid subspecies. Next on the list, we have strand beasts are Spec Evo.
The strand beast is a noble creature, graceful in its movements despite its extraordinary size. What's this? It appears the noble strand beast has located a food source. The poor human has no hope of escape whatsoever. Oh, it appears that the strand beast will go hungry for now. Godspeed, noble strand beast.
Hey guys, it's me again. Hope you enjoyed that little nature documentary. It's completely and 100% real. And just like that documentary, strand beasts are also real. And they're the invention of a Dutch man named Theo Jansen. They're made out of lots of different materials, but mainly PVC pipe and zip ties. Strand beast, by the way, is a word that means beach beast, so that's cool. So what are strand beasts exactly? Well, they're basically kinetic sculptures that move by wind power, possibly being pulled, and they walk in that manner as well. One quote from Theo Jansen, I think, really sums up his vision for what these strand beasts are, and he said, "The walls between art and engineering exist only in our minds." And I just think that's really cool because you have these giant creatures that are, moving along so beautifully, and it's a feat of engineering, but it's also a work of art. So that's really cool. But more than just being impressive and beautiful creations, these things have a full-on evolutionary tree created by Jansen. That's right. They began as a very simple organism living exclusively on Theo Jansen's computer, and as he built out multiple iterations, their family history began to branch off in numerous different ways, starting in 1990. So they haven't had a ton of time to develop. But that doesn't matter because their evolution has been rapid, to say the least, and has involved wind-based and wood-based creatures beyond just the PVC pipe that you see in most of them. And soon, it's theorized that they may even be able to fly. So yeah, honestly, these things are pretty amazing. And if this is your first foray into the world of kinetic sculptures, prepare to be oddly satisfied. The question, though, remains, why are strand beasts on this iceberg in the first place? Well, I think the real question is this: what constitutes speculative evolution or speculative biology? Must it necessarily be biology-based? I say no. I mean, it's pretty clear that Theo Jansen has created some amazing creatures that always build on previous iterations while also incorporating new features and new design ideas and even adaptations. These strand beasts even seem to take on a life of their own. like that one that tried to eat that lady at the beginning. So yeah, in summary, strand beasts are Spec Evo, and nobody can convince me otherwise. So we're moving on. Next, we have the living universe theory. Now, for most people, the universe is made up of material, non-living things. We're talking about rocks, microbes, just matter in general, and empty space. And in that empty space, there's nothing, it's a void. These are all non-living in the sense that they're not part of a living whole like an animal or a human is. But what if that's not the case? It's not that far-fetched of an idea, actually. Ancient cultures thought of the universe as being alive, and Plato famously described the universe as a single living creature that encompasses all living creatures within it. Another famous philosopher said it even better. You think the earth is just a dead thing you can claim, but I know every rock and tree and creature has a life, has a spirit, has a name. These days, a lot of scientists are pretty sure that the universe has a lot going on that we can't see. There's a ton of matter and energy completely invisible to us, and many people believe that there are multiple universes, a living, almost breathing expanse of energy capable of communicating within itself and even facilitating the creation and destruction of entire realities. The question is, where is the line between mysticism and science? Well, if we were to look at it from a purely scientific point of view, things get a little crazy. Big questions get brought up, like, is there an intrinsic consciousness to the universe? Or maybe this reality and others like it are all just part of a disk world, and we're all riding on the back of a cosmic turtle. But if the universe is alive, could it be a kind of organism that we're far too simple, too limited in our understanding to even comprehend it? Are we all just living in the stomach of Cthulhu? Nah. The Medea Hypothesis. The Medea Hypothesis is the idea that maybe, just maybe, the creator of the universe is not God, not the Big Bang, but Tyler Perry. Oh, sorry, that's some fan fiction I was working on. The Medea Hypothesis is kind of dark, actually. But before we get into what the Medea Hypothesis actually is, let's talk about something else called the Gaia Hypothesis. The Gaia Hypothesis is an idea or a thought experiment put forth by a chemist named James Lovelock. This was back in the 1970s. Basically, the idea is that living organisms on Earth and their surrounding environment, they all form a single, huge living entity as you look at them as a whole and through their interactions with each other. Not only that, but ultimately Earth's systems and control loops work continually to create the perfect conditions for life on Earth. So it's a very positive outlook. It's pretty nice to think about. It's kind of like a smaller scale version of the living universe theory, if you think about it. So now that we know what the Gaia hypothesis is, we can talk about the Medea hypothesis, which is pretty much the exact opposite. The only real similarity is that Peter Ward, who is the paleontologist who came up with this theory, thinks of multicellular life on Earth as a kind of superorganism as well. But that organism is not about furthering life or creating ideal conditions. It's suicidal, actually, and very destructive. So Mr. Ward pointed out that most extinction events on Earth are caused not by asteroids or giant cataclysms like volcanoes or something like that. Instead, they're more often by things like methane poisoning or a lack of oxygen as a result of certain imbalances, or in multiple cases, hydrogen sulfide poisoning. And these, in turn, are usually the result of some form of climate change. And in these events, microorganisms, they do pretty well, but other forms of life do not. So ultimately, his claim is that life on Earth wants to end itself, which is why there have been so many extinction events. And so, yeah, I mean, the idea of Earth and its organisms as a superorganism with a kind of collective consciousness that has a death wish, it's a bit of hyperbole that really only functions to make his general point, which is that life, it's not a positive thing, or at least it's self-destructive in a way that never ends up being good for anybody, except for microorganisms. So that's, a much more depressing way of looking at life on Earth. But it is an interesting one, I must admit. I don't really have a conclusion for this part, so we're moving on. Next, we have the Dinosauroid and Sleestack connection. Now, the author of this iceberg has been so kind as to put a caution here, so we better tread very carefully. So, buckle up, because this is about to get real interesting. Have you ever seen a TV show called Land of the Lost? Well, It's an old TV show that ran from 1974 to around 1985. And I must say, I never watched this as a kid. And even though looking at it now, I think it's a little bit silly, as a kid, I probably would have loved it. So it may be worth checking out. I think there's some episodes on YouTube. But anyway, Land of the Lost takes place in a kind of pocket dimension. And the titular land seems a lot like Earth, but with some pretty major differences. For example, dinosaurs and humanoid primates are there, as well as a race of sapient lizards called the Sleestack. That's their name. And so that's a little history for you. It's a little context. Here's where things get interesting. Around the same time as the television show's original run, around 1982, a paleontologist named Dale Russell came up with the thought experiment dubbed Dinosauroid. That's what it's called. He came up with this idea, and that's the name of it. And what did it involve? Well, he thought, hey, what if Troodon had never gone extinct? According to Dale Russell, it may have evolved similar traits to those we see in humans, like great intelligence and a similar body plan. So why did he come up with this, and why Troodon specifically? Well, he observed, basically, that up until Troodons disappear from the fossil record, their family line had been showing signs of large brain cavities, and much more so than any other dinosaur species at the time. They also had pretty good digital dexterity, if you will, fingers, great for manipulation, and even binocular vision, which, as you probably know, is kind of a nice thing to have. Now, overall, the Dinosauroid kind of goes back to our discussion on the humanoid body plan and how likely it is that there would be some type of convergent evolution, or that alien body plans would follow a similar pattern. But even at the time, many scientists thought that this model was way too similar to humans, but even still, it became very popular, and you've probably seen this image floating around on the internet at some point. But now, put on your tinfoil hats, because we're about to make a pretty startling connection. If you were to look at these two pictures side by side, wouldn't you say that the Sleestack and the Dinosauroid look strikingly similar? Well, as the author of this Iceberg pester Jess had brought to my attention, what if Russell's thought experiment was actually part of a very subtle marketing campaign for Land of the Lost? Well, that's probably not the case. Because after all, if this were true, then that would mean that if any one of Hollywood's elite thought that, some small YouTube person was onto them, then that small YouTube person could easily get disappeared. So, definitely no connection there. We're moving on to tier 8, and it starts with pure energy / photon-based life. So far in this iceberg, we've talked about silicon-based life, boron-based life, even plasma / dust-based life. There's so many things that life could be based on. Of course, we're based on carbon, which is so boring. But let's take it a step further. What about life that's based on pure energy? Well, have you ever seen the feature film Titan AE, a hidden gem of the late 1990s, in my opinion? In that really, really good movie, there is a race of bad guys called the Dredge, and they do appear to be based on pure energy. And that's what my mind always goes to if I think of something based on pure energy. It's the Dredge, one of the coolest bad guys in all of science fiction. But when it comes down to it, it's actually pretty hard to drill down and try to talk about the science about how a pure energy-based life form might exist. Fortunately, as with many things, we can move beyond the world of Titan AE and into the world of Star Trek for an idea. Star Trek has some what they call photonic life forms, and here's a picture, but there's also this type of being called a photonic, and what these are basically sentient holograms, so they're created by computers. They're not exactly what we're talking about here, but that's about all we get. I'm sure that there's been some kind of energy life form out there that I'm not aware of, but because the idea is kind of out there, and that's why it's so far down on this iceberg, that there hasn't been a lot of speculation on how that might happen. So if any of you have any ideas, be sure to let me know in the comments, because I'd be very interested to learn more. But that's about all we got. Next, we have the idea that all of Dougal Dixon's predictions are real. Do you remember our good friend Dougal Dixon, by the way? He wrote such popular hits as Man After Man and The New Dinosaurs. Well, guess what? All of those predictions are real. That man, nay, oracle of the scientific discipline, has bestowed upon us the wisdom of his all-seeing eye, which peers through the ages and into the very fabric of reality itself. That's right. all of his speculation is real. In the future, millions of years hence, a descendant of Jimez Smoot will return to Earth to find it overrun with humanity's dim-witted descendants, only to enslave them for his own industrial pursuits. And in another reality, dinosaurs develop fur to cope with frigid climates. It may be hard to believe, but this far down on the iceberg, our only source of light comes from the beacon of truth Dougal Dixon holds high above his head as he carries us in a caress more tender than a hiver holding a water seeker. So yeah, that's what this part of the iceberg is about. We're moving on. Every Spec Evo project is personalized. Now, I must be honest with you, I don't really understand what this is referring to, because I think by definition, any Spec Evo project is a personalization or an expression, if you will, of the individual artists who have undertaken that project. So there may be something more to this that I'm missing, but I have a very strong feeling, this is a spoiler alert, that this is one of those kind of tongue-in-cheek ones. So we're going to move on from that. Because now we see that at this point on the iceberg, we realize that all Spec Evo projects are real, also known as the omniversal biosphere. We've all seen Into the Spider-Verse, right? Of course we all have. For those of us who have seen Into the Spider-Verse, it's obvious that there are multiple dimensions, okay? That was the first movie to ever come up with that theory. And some very smart people also believe that there are infinite universes and an infinite number of realities. That means that, at least in theory, there is a universe where the Troodon didn't go extinct and evolve to become human-like. There's also a world where the Q invade our galaxy and turn us into pitiful abominations. Now, I don't know about you, but compared to that last one, I think this reality, we have it pretty good, all right? Is it possible, though, that every Spec Evo project has already happened, or indeed is happening now? Think about that for a second. What if the simple act of you thinking about that possibility caused a split in the universe timeline that brings about an entirely different reality for all of us? Yeah, now that's some speculation. All right, so it's been pretty jokey so far, kind of silly. We're just having fun. We're this deep into the iceberg, and it's just getting a little bit crazy. But we're about to talk about our last item on this entire iceberg, and so we need to take a moment, get all those laughs out, just settle down, and let's proceed with some reverence, okay? Because next on the list, we have Spec Evo waifu. All right, guys, so that's it. What a journey it's been, by the way. Thank you so much for joining me on this iceberg. Now, I know there were some relatively large projects that didn't make the list, but if one of your own favorites didn't make an appearance on this iceberg, well, let's just say it takes more than one giant chunk of ice to sink a ship, if you know what I'm saying. So once again, thanks for watching. Thanks to Pester Jest for helping out with some of the details of this iceberg. I'll leave a link to some of their works in the description, so you should definitely check that out. And otherwise, stick around, because I've got a lot more planned for this channel. Because after all, there is a living universe out there with more stuff than I could possibly hope to cover, but we're going to try our best. So once again, thanks for watching.